Hi everyone, welcome to goclasses. In this lecture, we will continue our discussion of SQL. So this is SQL Complete Summary Part 2. Remember, in this SQL Complete Summary, I am discussing all the important concepts, all the important points, all the type of questions, all tricky questions, everything. So if you did not watch the main course of SQL, then don't worry, you can watch the complete summary and you can solve all the gate previous year questions. You will be able to solve each and every gate previous year questions after watching this SQL complete summary. So let's start part 2. The part 1 link you can find in the description, so you can check it out. So let's start now. These are the recap. You already know that in SQL, our table is a bag of tuples. Yes or no? In our table, we can have duplicate rows. You can easily see, for example, this row and this tuple, these are same tuples. They are duplicate. So we already know that SQL works on the bag semantic. Means in SQL, every table is a multiset. Every table is a bag. Okay. And remember, if you apply the where condition, okay, for example, here, what this means c greater than 6. Okay, so this is basically what this query means. This query means that from this table R, so if I apply this query that from this table R, where, okay, those tuples I select where c value is greater than equal to 6, okay, select star means I am projecting all the attributes. Okay, this star means I am projecting all the attributes, and this is the tuple selection condition. So if I apply, you can see this query, if I run on this table, then this will be the output. Yes or no? You can easily see this tuple will be gone because this is the tuple selection condition that c value must be greater than or equal to 6. So this will be the output. You can easily see the output is also bag of tuples. In the output, you can easily see that these tuples, they are same. Yes or no? Okay, so very simple. Now let's move on. Now let's see null values in SQL. This is our next topic, how to handle null values in SQL. So first of all, what are null values? You already know. So null values have different meanings. Remember, in many different situations, you can use this null value. For example, if you don't know the value, then you can use null value. Like for example, your grandfather birth date. Okay, we don't know. Yes or no? Many of us, we don't know the birth date of our grandfather. Okay, then in that case, we can put null there. Okay, so this is unknown. Yes or no? So we can put null value. If if the value is inapplicable, then also you can put the null value. For example, if I ask you, what is your Ferrari number? Okay, your Ferrari or Lamborghini. Okay, what is the number of that? So that that will be null. Okay, because that is inapplicable to you. Can you understand the difference between these two? For example, your grandfather birth date, okay, that is unknown. That is unknown, we can put null value there. But that exists, right? Yes or no? That will exist. Okay, that exists definitely. So there was a day when our grandfather, he was born. Yes or no? So definitely that exists, but we don't know. But we don't know the value, so we can use null value. Now understand this inapplicable value. For example, what is the Ferrari number or Lamborghini number of my Lamborghini? So that is inapplicable because I don't have Ferrari. Okay, so that is inapplicable because my Ferrari car does not exist. I don't have that. Or empty placeholders. For example, whenever you are filling a form, many times what you do, you leave the column empty. Yes or no? Yes or no? For example, you are filling a form. Okay, then this column you can keep it empty, right? Without filling, without recording the value, you can move on. Okay, so very simple that you can use null value in this type of situation also, empty placeholders. So very simple point that this same value null we can use in many different situations. Okay, means when we don't know the value, we can use null. When it is not applicable, we can use null. When it is absent or not recorded, then we can use null. So in different situations, we can use the null value. Is this clear? Very simple point. Okay, there are many different situations in which we can use null values. Okay, null simply means that we don't know the value, or the value does not exist, or the value is not applicable, or the value is not recorded. Okay, so there are many different situations in which this null value can be used. For example, consider this question and tell me, if employee dot if employee dot spouse, if that is null, then what is the most probable situation? Tell me. If employee dot spouse, in the employee table, the spouse column, okay, in this employee table, if the spouse column is null, okay, then what is the most probable situation? Can I say the spouse name is unknown? No, the most probable situation is this. Yes or no? Anyway, don't worry. In the gate exam, they will not ask you, but this is just for understanding. Okay, this is just for understanding that in the employee table, if I ask you, if I say that spouse column is null for some employee, okay, for some employee Raju, if the spouse column is null, then it simply means that Raju is unmarried. Okay, very simple. So you can see the point is that we can use null value in many different situations. Okay, now remember, no one will ask you that this particular null value is used for which situation. No one will ask you. I'm just telling you that there are many different situations when we don't know the value or the value does not exist. In those situations we can use the null value. Okay, so null value has many different meanings. Okay, yes or no? These are most common meanings, but there can be some other meaning also, remember. Okay, so null value has many different meanings. Now let's move on. Now, one very important rule I want to tell you about null value, that is arithmetic operation with null value, the result will be null value. Okay, this is a important result. Remember, this is an important rule for null value. For example, if I ask you what is 50 plus null, what do you think? What should be the answer? See, null value, either it does not exist or this is unknown or this is not applicable. So this null value plus 50, what should be the result? The result must be null value. Okay, very simple. So null value, remember, if you do arithmetic operation, this is arithmetic operation, correct? Yes or no? Okay, this is a arithmetic operation. So arithmetic operation, when I do with null, then the result will be null. Okay, so you can easily see the arithmetic operation with null, that is null. Okay, 50 plus null, that is null. Now you tell me a very simple question I'm asking. What is null multiplied by 0? Tell me, what is that? Null multiplied by 0. That is also null. See, there is no exception. There is no exception. Remember one thing. If you have null, okay, null with null, if you do any arithmetic operation, okay, if you do any arithmetic operation, okay, this can be anything. This can be anything. Then the result will be null. So remember, this can be anything. Okay, so null multiplied by 0, that is also null. Okay, for example, if I ask you what is null minus 0, that is also null. Remember. Okay, so for example, if I ask you what is null minus null, that is also null. Okay, because remember, this can be anything. When I say anything, this can be null or not null. This can be null or not null. This can be anything. So with null, if you do arithmetic operation, then the result will always be null. This is a very simple point. If I ask you, for example, 0 divided by null, what that will be? 0 divided by null, that also will be null. Okay, so this is a very simple result. This is a very important rule. So remember, whenever I perform arithmetic operator with null, then the result will always be null. There is no exception. For example, null multiplied by 0, that will be null. 50 multiplied by null, null. Null divided by null, null. Null minus 50 is null. Null minus 0 is null. Okay, so very simple point. Now let's move on. Now tell me one more thing. If I say that this in the question, if I say that this is a column A, okay, this is your table R, and this is column A, I tell you that domain is integer. I tell you that domain is an integer. Okay. Now you tell me the domain is integer, remember. Now you tell me if I say that null minus 0, now what that will be? If I tell you that domain is integer, now tell me if I ask you what is null minus 0, now what that will be? Again, that will be null. Remember, arithmetic operation with null is always null. There is no exception. Is this clear? Okay, so to confuse, they can give you that, okay, this is integer, this is anything. Whatever, it doesn't matter. Whatever is the domain, it does not matter. I can say arithmetic operation with null, that is always null. So very simple. You can read it here. For example, null minus null, that always will be null. For example, null multiplied by 0, that also will be null. Okay, there is no exception, remember. So this domain is integer. This is just to confuse. Okay, so that you will think, okay, domain is integer. So if I multiply by 0, then it should be 0. but actually this will be null. Okay, don't say that this is 0. So very simple point. Arithmetic operation with null is always null. So this is the idea. Null arithmetic operation, anything. And this anything can be null or this can be not null. The result is always null. Now let's move on. Now let's see aggregate operators in case of null values. So far we have seen aggregate operators without having null values in the table. Now if you have null values in the table, then how the aggregate operators will behave, that is what we need to study. Okay, so let me tell you that all the aggregate functions, they ignore the null values. They will ignore the null values. Okay, remember all the aggregate functions, but the only exception is count star. This count star will always count the number of tuples in the table. It will not ignore the null value. Okay, so remember, every aggregate function will ignore the null value, but the count star, this count star is special. If you remember, I told you in the last session that count star will always count the number of rows in the table. Okay, it does not ignore the null value. So it is special. So remember, always study this separately. Don't confuse count star with count of A. Okay, so let me tell you here. So all the aggregate operators, they will ignore the null values. For example, if you have table R, let's assume in this table R, I give you this attribute A, and let's assume you have these values, for example, 2, -3, null, 0, null. Okay, so let's assume these are the tuples. Now, in this situation, if I ask you what is count of A, then what that will be? What is count of A? What that will be? Count of A. Remember, this aggregate operation will ignore the null values. So count of A will be 3. Okay, this will ignore the null values. Remember, count star is special. Okay, I told you in the last lecture also, I told you that count star, this is special. This will always, this count star, this will always count the number of tuples in the table. So that will be 5. So remember, count star is special. This count star. Okay, don't mix this count star with the other aggregate operations. All the aggregate operations, other aggregate operations, they behave in the same way. They behave in the same way. Okay, so for example, count of A, that will be 3. If I ask you what is sum of A, what that will be? Sum of A. Remember, aggregate operations, aggregate functions, they ignore the null values. They will ignore the null values. So what will be sum of A? Sum of A will be 2 minus 3 plus 0. Okay, so that will be -1. Yes or no? Okay, so very simple. What is max of A? That will be 2. What is min of A? That will be -3. What is average of A? AVG of A? That will be summation divided by count. Yes or no? That will be summation divided by count. So -1 divided by 3. Is this clear to everyone? So remember, they will ignore null values. They will ignore null values. Okay, so all the aggregate operators, they will ignore the null values. Now you might be thinking, sir, why they are ignoring the null values? Are you thinking that why we have this rule in SQL? We have this rule that all the aggregate operations, all the aggregate functions, they will ignore the null values. But why they are ignoring the null values? Do you have some intuitive explanation? Intuitively, can you understand? Very simple. See, just think about it. If let's assume you have this table, and in this table you have some salary column. Okay, some salary column. Now you tell me, in this column, let's assume there are 1,000 tuples. Just think about it, that there is a salary column and there are 1,000 tuples, and one of them is null, and one of them is a null, maybe, or maybe two of them are null, and all other are not null. Okay, all other are salary, maybe 20, 10, 10. Okay, 30, so like that. So now you tell me, if I want summation of salary, if I want to calculate sum of salary, and think about it, if I don't ignore the null values, then what will be the answer? If I do not ignore the null values, then what will be the answer? If I do not ignore the null values, see, if I do not ignore the null values, then null plus anything is null, that you already know. Yes or no? If I do not ignore the null values, then null plus anything is null, that you already know. I told you, arithmetic operation with null are always null. This is what we have seen. Arithmetic operation with null, the result will always be null. So if I do not ignore the null values, then the result will be null. Do you agree with me? Okay, this will happen if we do not ignore null values. If this sum does not ignore null values, does not ignore null values. Okay, now just think about it. There are 1,000 tuples and I want to calculate the total salary. This is what I want to calculate, but because of one or two null values, you can't calculate. Do you want that? Please tell me. There are 1,000 tuples. I want to calculate the total salary, but because of one null value, because of single null value, or maybe two null value, because of them, because of null values, I cannot calculate the total salary. That we don't want. Yes or no? So this is the intuitive explanation. Forget about it. You can forget about it. Okay. So just remember that SQL will always ignore these aggregate functions, will always ignore null values. Okay, in SQL, aggregate functions, they will always ignore null values, but count star is special. This will always count the number of tuples in the table. I told you that count star, this is exception. This will always count the number of tuples in the table. So all these aggregate functions, count, sum, max, min, avg, they will behave in the same way, and this is a special aggregate function. Okay, so don't mix this count a, count star, do not mix them. I told you, do not mix them. Okay, you can put a meme here. For example, this count, what this will say to count star, हम अलग हैं, हमें खुद से मत जोड़िए. You know, there is a meme, we are different. Okay, don't include me in your category. So very simple, there is a meme, if you remember Gangs of Wasepur movie meme. So you can put here, okay, that we are different. So remember, these are different, don't mix them. Same but different. Yes, same but different. Okay, so let's move on. Now let's see, if I have distinct, then what will happen? For example, let me give you let me give you 2 here, and let me give you some value minus 3 here. Now you tell me, if I put count distinct a, then what will be the answer? Count distinct a, what that will be? Remember, this count will ignore the null values. Who will ignore the null values? This count will ignore the null values. So first you ignore the null values. Now you count the distinct a. So that will be, answer will be 3. Yes or no? Because this count will ignore the null values. First you ignore the null values, because this count will ignore the null values. Then you count the distinct values of a. So the answer will be 3. Yes or no? If I ask you what is sum of distinct a, what that will be? Again, this sum will ignore the null values. Then you count the summation of distinct values of a. So the summation of distinct values of a, that will be -1. Okay, if I ask you what is max distinct a, that is same as max a. That is same as max of a. And that will be, you ignore the null values. This max will ignore the null values. Then you find the max value. The max value that will be 2. Yes or no? What will be the min value? Min of distinct a. That is same as min of a. Okay, and that will be -3. Remember, this min, this will ignore the null values first. First you ignore the null values, then you find the minimum value. Okay, what will be AVG of distinct A? So this AVG, it will first ignore the null values, then you find the average of distinct values of A. Okay, so AVG of distinct A, that will be sum of distinct A divided by count of distinct A. So the answer will be -1 divided by 3. Is this clear? Very simple, right? Okay, now you tell me what will be count star. What will be count star? This will always count the number of tuples in the table. Okay, so for this, the answer always will be 7. Is this clear? So very simple point. Now, let me tell you, aggregate function on empty table. If you have empty table, then what will happen? So that is what we need to see. If you have empty table, then what is going to happen? So let's assume you have a table R, and in this you have this column A. Okay, maybe you have multiple columns, and this is empty. There is no tuple. This is an empty table. Now, if this is empty table, then what are the rules? Now, first of all, you tell me what is the count star, because this is special. This will always count the number of tuples in the table. Okay, so first you tell me this. So what is count star? This will count the number of tuples in the table. So that is 0. Number of tuples is 0. Yes or no? There is no tuple, so number of tuples is 0. Now look at the remaining. Okay, so there is a rule that if I ask you what is count of A, then what that will be? For empty table count, this will be 0. Okay, count of A will be 0, and for the remaining, the answer will be null. For example, if I ask you sum of A, that will be null. If I ask you AVG of A, that will be null. If I ask you max of A, that will be null. And if I ask you min of A, that will be null. Is this clear? Okay. So these are the rules. Remember, when you have empty table, in case of empty table, these are the rules. Is this clear? These are the rules. So very simple. Remember, count of A will be 0. When you have empty table, then count of A will be 0. But the remaining you can easily see they will be null. For example, if I ask you what is count of distinct A, what is count of distinct A? Now tell me. It doesn't matter. It will it will again be 0. Count of distinct A, that will again be 0. Okay, and for the remaining, if I put distinct, it doesn't matter, that will be null. If I put sum of distinct A, that will be null. If I put mean of distinct A, that also will be null. Okay, is this clear to everyone? Please tell me. So these are the rules when you have empty table. In case of empty table, what will happen? These are the rules. Okay, and what is count star distinct? Count distinct star, what that will be? Count distinct star, that is invalid. Yes or no? Okay, so this count star is special. So if I put distinct, count distinct star, this is invalid. And if I put, for example, count star some variable, some attribute A, some attribute A, now these are invalid. These are invalid. Okay, is this clear? So remember, they are invalid. So count star is special. Count star has no variations. Count star is simply counting the number of tuples in the table. Okay, yes or no? There is no, I can say, there is no hidden point here. Count star has no hidden secret point. Okay, this is very simple. Count star, this is the single semantic syntax. This is the only syntax. You cannot use distinct, you cannot use attribute name. This is the syntax, and meaning is also very simple, that count number of A's and number of rows. It will count number of rows in table. It will not ignore the null values. It will always do this. So very simple. I hope you understood all these points. So remember, when you have empty table, if you have empty bag, then the count value will be 0, and for all the remaining aggregate operations, the result will be null. Okay, you can easily see the count value will be 0 when you have empty table, but for all the remaining aggregate functions, you can see the answer is null if you have empty table. Is this clear? Simple, right? Now you tell me the answer for this question. Let me know the answer for this question. Suppose we have a relation RAB with one tuple. This is the only tuple, null, null. Now, both the components are null. Now you tell me what will be the value of sum of A. If I ask you what is going to be the value of sum of A. Okay, so tell me. For example, in this case, you tell me what is sum of A. See, just apply the concept that you know. What is the concept? The concept is, I am asking sum of A. Okay, so what you will do? Very simple. Sum of A, that will ignore the null value or not? This will ignore the null value, right? Okay, very simple. This will ignore null value. Ignores null values. Do you agree with me? This will ignore the null value. So first it will ignore the null value. If you ignore the null values, then what it will become? This sum, this will ignore the null values. Now once you ignore the null values, then what you will get? You will get empty table. Yes or no? First you ignore the null values. Now after ignoring the null values, we get empty table. Correct? I can say after ignoring null values of A, we get empty table. And for empty table, what is the sum value? We get empty table. Yes or no? And remember, for empty table, what is the sum value? that will be null. So the answer is that sum of a, that will be null. I hope this point is clear. Is this clear? Let me know. So remember the aggregate operation, this aggregate function, this will ignore the null values. So once you ignore the null values, this null value, once you ignore, then you will get empty table. And for empty table, the sum equal to null, that you already know. Now you quickly tell me, so sum of a will be null. What will be count of a? That will be 0. Remember, count will ignore the null value. You will get the empty table. And for the empty table, the count is 0. Yes or no? Now, one interesting point. What is count star? One interesting point. What is count star? This is special. This will always count the number of tuples in the table. So the answer will be 1. Yes or no? Is this clear? So that is the reason don't mix count star and count a. Yes or no? Do you agree with me? They are of different category. Don't mix count star, count a. They are different. Study them separately. This is special. You can consider this special. Okay, so count a, that will be 0. Why? Because count a, this count will ignore the null value. Now this column a is empty. For empty table, the count value will be 0. That you already know. Okay, now you tell me what is min of a. That also will be, that will be null. Min of a will be null. Okay, now you tell me what is AVG of distinct a. That also will be null. I hope all these points are clear to everyone, right? Agree? For example, if I give you this table, let's assume you have a table A, B, okay, and you have all the tuples of A are null, 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 okay, and let's assume here you have 2, null, 2, okay. Let's assume this is what you have. Now you tell me in this situation, quickly tell me all the answers you tell me. For example, first of all, you tell me count star. First of all, you tell me count star. That will be 3. That will be number of tuples. Yes or no? Now you tell me what is count star of B. What is count star of B? This is invalid. Yes or no? This is invalid. That you already know. This is invalid. Okay. Now you tell me what is count of A. See, count of A. What it will do? This count will ignore the null values of A. Ignore the null values of A. Now this A is empty. For empty, the count is 0. Okay. Yes or no? Next. Next, what is count of B? What is count of B? This count will ignore the null values of B. So now the count of B, that will be what? That will be 2. Okay. Now if I ask you, what is count of distinct B? Count of distinct B. This count will ignore the null values of B. Now you count the distinct values of B. So that will be 1. Okay. So very simple. Now you tell me about sum. What is sum of A? This sum will ignore the null values of A. For empty table, the sum is null. For empty table, the sum is null. That you already know. Okay, very simple. If I ask you what is sum of distinct A, distinct B, if I ask you the sum of distinct B, this sum will ignore the null values of B. Now you calculate the sum of distinct values of B. So that will be 2. Okay, so I hope all these points are clear to everyone. Everything is clear, right? Very simple. So let's move on now. We have seen all these points we have seen. You can check it out. Now let's move on. Now let's see null values in SQL. So far we have seen aggregate operations, or I can say aggregate functions. Are they clear? Aggregate functions in case of null values. Okay, everything is clear. Let me know. I have taken all the variations related to aggregate operations, aggregate functions. Now let's see null values in SQL, how to handle null values in SQL. So far, if you remember in the last lecture, in the SQL summary part 1, we did not consider the null values. Do you agree with me? So far, most of the time, we did not consider null values in the tables. But now we will consider the null values in the tables. Now we will see null values in SQL and their effect on anything else. Okay, on all the concepts. What will this null value, how the null value will affect? This is what we need to study. Okay, so now we will study null values in SQL and their effects on everything else. So first of all, let me tell you what are arithmetic operations and what are comparison operations. Do you understand the difference between them? For example, if I ask you, this addition, is this arithmetic operation or comparison operation? This addition is arithmetic operation. This subtraction is arithmetic operation. Division, multiplication, these are arithmetic operations. Yes or no? Agree? For example, logarithm, this is arithmetic operation. Yes or no? All these points, all these things, these are arithmetic operations. Now you tell me about comparison operations. What are comparison operations? Let me know. What are the comparison operations? In SQL, we use only these arithmetic operations, so you can forget about this, but this is also arithmetic operation. Okay, so you tell me about the comparison operations. For example, A is equal to B. Is this comparison or not? Are you comparing them? Are you comparing them? Yes, we are comparing them. Yes or no? For example, A is less than B. Are we comparing them? Are we doing comparison? Yes, we are doing comparison. So comparison operations are, for example, equal to, not equal to. Remember, this is same as not equal to. This is the symbol for not equal to. Is this clear? This is a symbol for not equal to. Symbol for not equal. Okay, is this clear? So this is the symbol for not equal. Okay, what about this? Less than. This is less than. This is less than equal to. This is greater than. This is greater than. This is greater than equal to. Okay, yes or no? So these are the comparison operations. I hope all these points are clear. Okay, arithmetic operations, comparison operations. Now let me tell you very important rule about null values. Okay, just understand these two rules and you can solve any question based on null values. What are the rules? These are the important rules. Arithmetic operation with null value, the result will always be null value. If you perform arithmetic operation with null value, then the result will always be null value. And when you perform comparison with null value, then the result will be a new truth value that is unknown. Okay. So remember, arithmetic operation with null value, result is always null value. Comparison operation with null value, the result is always a new truth value that is called unknown. Now you might be thinking what this unknown means. Let me tell you, what are the truth values that you know? What are the truth values that we know? Truth values. For example, you know, this is a truth value true. Okay, this is a truth value false. Yes or no? Normally, this is what happens. The truth values in Boolean algebra. Can I say in propositional logic? In Boolean logic. Agree with me? In the propositional logic or in the Boolean algebra, these are the truth values. But in SQL, there are three truth values. SQL has three truth values. So let me tell you truth values in SQL. Truth values in SQL. So there are three truth values in SQL. One is true. You can write it T. Another is false. You can write it F. Another is unknown. This is a truth value. You can write it U. Is this clear? So remember, SQL uses three valued logic. Remember, in the propositional logic, in the Boolean algebra, we use these truth values, true, comma, false. Okay, but SQL uses three valued logic. Means in SQL there are three truth values. Those are true, false, unknown. Okay, one more thing I want to tell you that, see, look at this second rule. Comparison with null is unknown. Means what it means. For example, if I do a null less than 50, what will be the answer? Tell me. And if I do null plus 50, what will be the answer? Tell me the answer here. Tell me the answer here. See, this is arithmetic, right? Yes or no? This is a arithmetic operation. So arithmetic operation with null value, what will be the result? This is arithmetic operation. Arithmetic operation with null value, the result will always be null value. Okay, this is comparison, right? This is comparison operation. Comparison operation with null value, the result is unknown. Okay, what is this unknown? This is a new truth value. Remember this unknown, this is a new truth value. Is this clear? This is a new truth value. So remember the difference. Null plus 50 is null and null less than 50 is unknown. Means this is comparison operation. Comparison with null, that is a truth value that is unknown. Okay, is this clear? Is this point clear? For example, what is null multiplied by 0? That is null. That is null. Very simple. But you tell me, what if I write null is equal to 0? Now this is arithmetic operation and this is unknown. Correct? Yes or no? Now this is comparison. Now this is comparison, so this will be unknown. This is comparison. So this will be unknown. Very simple. All these points are very simple. For example, what is null less than equal to null? What that will be? Again, that will be unknown. Okay, because this is comparison, so the result will be unknown. I hope all these points are clear. Okay, for example, what is 0 divided by null? Now this is arithmetic. This is arithmetic, so the result will be null. Simple. All these points are very simple. Now, one thing I want to tell you, many students, they don't understand the difference between null and unknown. Null versus unknown. Are they same? Are they same? Tell me, are they same? If they are same, then why are we doing so much examples? Yes or no? Why are we doing so many examples? Correct. Okay, just think about it. If they are same, then why do we have two different rules? There is no need of two different rules. Okay. So remember, there is difference. Null comma unknown, they are different. Okay, what is null? Tell me, what is null? This is a missing value. Can I say? Can I say this is a missing value? Tell me, null is a missing value, or either you can say null is a missing value, or you can say this is not known value. We don't know. Not known value. Or this is not applicable value. Yes or no? Not applicable. Basically, null has many different meanings. Do you agree? Or not recorded value. Not recorded value. So null has many different meanings. I can say null is basically a missing value. Something that is missing. That is missing. Null is a missing value. What is this unknown? This is a truth value. This is a truth value. Is this clear? This unknown, this is a truth value. Okay, because there are three truth values. One is T, one is F, another is unknown, that is U. Unknown, or you can say U. These are the truth values. Okay, so remember, unknown is a truth value and this null, this is a missing value. So I hope you understood the difference. So if I say, for example, if you say, many students, they casually say, I have seen many students, they casually say that, okay, null less than 0. So comparison, this is comparison. Okay, so the result will be null. Is this correct? Is this correct? This is wrong. Okay, remember, null, if you do comparison, comparison with null is a truth value that is unknown. Okay, this is a truth value that is unknown. That is unknown. Similarly, remember, if I do arithmetic with null, for example, if I do null plus 50, then some students, they casually say, okay, that this is unknown. But this is wrong. Null plus 50 is actually null. Okay, so very simple point. I hope you understood this. So null versus unknown, they are different. Null is a missing value, or not known value, or not applicable value, or not recorded value. Null has many different meanings. Okay, but unknown, this is a truth value, because SQL uses three valued logic. I told you. Okay, so let's move on now. So very simple point. You can see this is a screenshot from the Ullman book. This is screenshot I've taken from the Ullman book. Okay, so you can easily see that arithmetic operator with null, that result will be null. Okay, but when I do comparison with null, then the result will be unknown. And this unknown is a truth value. This unknown is another truth value like true comma false. Okay, this is another truth value like true comma false. Now we will study the properties of this unknown. This is what we need to study now. Okay, is this clear so far? Everything is clear? So let's see. Now we will see the three truth values in SQL. Okay, we will see their property. These are the truth values: true, false, unknown. These are the truth values. So first of all, let me tell you that SQL's three valued logic. What it means? It means SQL uses three valued logic, remember. Okay, whenever you have null values, then there are three valued logic SQL uses. What are these three? What are these three valued logic? What are these three truth values? Tell me. In SQL. In SQL, we have three truth values because SQL uses three valued logic. Okay, and those are T, comma F, comma U. Very simple. Now we will see the property of this U because you already know the property of true, comma false. Yes or no? Property of true, comma false. I already know. For example, true and true. Tell me what is that? That is true. You already know. For example, true and false. What is that? That is false. If I ask you what is false or false, that is false. False or true, that is true. So you already know the properties of true, comma false. But what we need to see? We need to see the properties of unknown. Do you agree with me? So now we need to see, for example, if I do true or unknown, then what that will be? Okay, we need to see the properties of unknown. For example, if I do false and unknown, then what that will be? If I do unknown or unknown, what that will be? Okay, and so on. So this is what we need to study now. I hope this point is clear. So let's move on. So remember, we know that comparison involving null values, that will result, the result will be a truth value that is unknown. Now we need to see the properties of this unknown. We must study, we must learn the properties of this truth value unknown. So let me tell you, this is actually very simple. So let's quickly see. See, there is a trick. There is a trick to remember the properties of unknown. Trick to remember. Okay, trick to remember properties of unknown. So what is this trick? Okay, what is this trick? Let me tell you. The trick is something like this, that this true, you consider this as 1. This true you consider as 1. Okay. This false you consider as 0. And this unknown you consider as what? This you consider as something middle half. Okay, yes or no? So remember, you can, this is a trick to remember the properties of unknown. True consider as 1, false consider as 0, unknown you consider as 1 by 2. Now this is very simple, that if you do and, okay, anything and anything, for example, remember this x and y, then what will be the result? If I do x and y, then the result will be whichever is minimum of them. Okay, whichever is minimum of them, minimum of x comma y. Is this clear? So remember, and that simply means minimum of x comma y. And if I do or, then what I will get? X or y. Then just find the maximum of x comma y. Just find maximum of x comma y. This or you find maximum. Okay. And if I ask you not of x, then what you will find? If I ask you not of x, then you will just calculate 1 minus x. Not of x will be 1 minus x. Okay, if I ask you not of x, then that will be 1 minus x. So this is property. This is the trick to remember the properties. Is this the concept? Is this the concept or is this just a trick? This is just a trick. This is not a concept. Okay. Actually, see, let me tell you, this is just a trick. Actually, all the properties, see, all the combinations, they are actually already defined. Means, for example, what is true or unknown, false and unknown. Actually, these are defined. Okay, these are already defined. We cannot do anything. These are already defined by the SQL. Who decided what will be true or unknown? Who decided? SQL. Who decided what this value will be? SQL. So remember, these are actually defined, but to remember them, we have a trick. So this trick is just to remember the properties of unknown. Okay. And don't worry, this trick is given in all the standard resources. Okay, like you can see, this is Ullman book. In this Ullman book, also the same thing is given. You can see the rules are easy to remember with the trick. Okay, if you want to remember the rules, then you can use this trick. So very simple. This is the trick, that and means you just take the minimum of both of them, or means you take maximum of both of them, and not means 1 minus x. And remember, true means 1, false means 0, unknown means 1 by 2. Okay, is this clear? Now you quickly tell me all the things. For example, let's assume x and y. Okay, these two I am taking. I am asking three things. I am asking what is x and y. I am asking what is x or y. I am asking what is not x. Okay, so let me fix x. X I am fixing true. Okay, so x I am fixing true. Remember, now I have y either can be true or it can be false or it can be unknown. Now you tell me the answer. What is true and true? This is very simple. This is true that you already know. But can you apply the trick? You can apply the trick, right? You can apply the trick because true means one. See, true means one, right? And what is and? And means max. Sorry, and means min. And means min. So what will be true and true? Okay, that will be min of them. Min of 1 comma 1. That will be 1. Okay, so you can apply the trick. What is true or true? That will be true. Because or means max. Yes or no? True means 1. Or means max. So if I ask you what is true or true, so that will be max of 1 comma 1, that will be 1. And that means true. So the answer is true. What is not of true? That will be 1 minus 1, that will be 0. That means false. Okay, not of true is false. So you can just apply this trick. Not of x is 1 minus x. So for example, if I ask you, remember true is 1. Okay, so if I ask you what is not of x is 1 minus x. So if I ask you what is not true, so that will be 1 minus 1. So that will be 0. And 0 means false. And 0 means false. Okay, so very simple. You can just apply the trick. Now you tell me true and false. That you already know false. True or false. That will be true. Negation of true will be false. Okay, what is true and unknown? Let me know. True and unknown. Please tell me what that will be. I am asking true and unknown. Remember, true means 1, unknown means half, and means min. So you just take min of them. Min of 1 comma half. So that will be half, and that is unknown. So your final answer is unknown. Okay, this is unknown. What is true or unknown? Let me know. True or unknown, that will be true. Okay, easily you can do true or unknown. True or unknown. So that will be max. Max of 1 comma half, that will be 1, that is true. Simple. Okay, and what will be negation of true? That is false, that you already know. Okay, not of x. So now you similarly you tell me, now I'm fixing this x to you, unknown. Okay, now you tell me true, false, unknown. What will be the answer? So for example, let me know u and t. U and t, that will be u. Just take the minimum. U or t, just take the maximum. Negation of u. Remember, not of u. That will be 1 minus u. 1 minus half. That will be half. Half means u. So this is unknown. Yes or no? Similarly, u and f. That will be f. Okay, u and f, that will be f. U or f, that will be u. Okay, so negation of u, that is u. U or u. U and u. Tell me, u and u. So that is max, that is minimum of them. That is minimum of them. Minimum of half comma half. That is half. And that is half means unknown. So this will be unknown. U or u. That will be maximum. So that will be u. This will be u. Okay. So like this you can do. Agree? Now similarly, if I fix this as f, false, false, false. Now you tell me quickly, true, false, unknown. Now let me know the answer. False and true, that is false. False or true, that is true. Negation of false is true. False and false, that is false. False or false, that is false. Negation of false is true. False and unknown, that is false. False or unknown, that is unknown. And false complement, not of false, that is true. Okay, is this clear to everyone? Please tell me. So you can see and means you just take the minimum of them. Okay, this is the trick. You can see and means minimum, or means maximum. Correct. Okay, so you can easily see or means just take maximum, and negation means 1 minus v. So this is the trick. And remember, unknown is half, true is 1, and false as 0. So all these simple points you can easily understand. So let me use different colors. I have many colors, so I can do that. Okay, so like this you can easily see. Okay, let's move on now. So this is the entire table. You can easily check. Okay, for example, quickly tell me, if I ask you what is unknown and unknown? Unknown and unknown, that is unknown. Yes or no? What is false or unknown? That is unknown. Yes or no? Is this clear? False, unknown and true. Unknown and true, that is unknown. Okay, so you can easily see all these things. And the note of unknown is unknown. Now let's move on. Now let's see where clause. In the where clause, we put the tuple selection condition, right? Where clause means tuple selection condition. Now, this tuple selection, when you have null values, then how it will happen? So let me tell you the answer. The where clause, or I can say the tuple selection condition, that will satisfy if the answer is true. Okay, if the condition satisfies true, okay, I can say if the condition evaluates to true, then that row will be selected. If the condition becomes false or unknown, then that tuple will be discarded. Is this clear? Very simple point, that where clause, very simple, where clause will return a row whose result is true. But if the result is unknown or result is false, then that row will be discarded. Okay, so very simple point. So let me tell you that what this where clause will do. Okay, what this where clause will do. This will check tuple by tuple, yes or no. This will check tuple by tuple, tuple after tuple, tuple by tuple. Okay, independently, that you already know. Now let me tell you, if tuple, if condition becomes, if tuple selection condition, okay, I can say that if this tuple selection condition, okay, evaluates, if this tuple selection condition evaluates to false or unknown, false or unknown. Now tell me, if this tuple selection condition evaluates to true, false or unknown, then that tuple will be what? Then that tuple will be what? Then that tuple will be rejected. Yes or no? That tuple will be rejected. So when the tuple will be selected, tuple selected only if a condition becomes true. Tuple selected only if condition becomes true. This where condition becomes true. Okay, is this clear to everyone? Please tell me. So very simple. Remember, where clause will return only those tuples for which the result is true. If the result is false or unknown, then that tuple will be rejected. Okay, let's see one example. Consider this. Consider this query. Consider relation R. You have a relation R with single integer attribute A, and this is the query. Now let me give you the table. Okay, let me quickly give you the table. So you have this table R, and this is A. Now let's assume these are the values. Integer attribute, right? You can have -1, 1, -1. Let's assume you have null, you have null. Okay, let's assume these are the tuples. Is this clear? Now you tell me how many rows, how many tuples this query will give you in the output. Let me know. Number of tuples in the output. Find number of tuples in the output. So tell me, what is that? Number of tuples in the output. Pause the video, write your answer in the comments. So let's see. So very simple. From R, this is the table R. This is the conceptual evaluation step number one. Yes or no? Step number one from R. So this is your table R. Very simple. Next, step number two is this. So where? This is your step number two. Okay, and this is your tuple selection condition. This is the tuple selection condition. And what this condition is saying, this is saying that A is less than equal to 0 or A is greater than 0. Okay. See, it looks like that this will always be true. Yes or no? Do you agree with me? It looks like that this will always be true. A is greater than 0 or A is less than equal to 0. It is looking like that this will always be true. But something will happen if A is null. If A is null, then something else will happen. Because remember, in SQL, we have three truth values: true, comma, false, comma, unknown. Okay. Yes or no? So now let's see. Now you can easily see for this tuple, remember where this will apply tuple by tuple. Yes or no? That you already know. So let me write it here. This where it will apply tuple by tuple independently. So let me write it here. Applies on every tuple independently. Applies on every tuple one by one, individually or independently. So now you tell me, for this tuple, this condition will be satisfied or not? Let's call it condition C. Let's call it condition C. Okay. So you tell me, for this, the condition will be satisfied or not? Yes. So for this condition, remember, I can say the condition becomes what? The condition C. That will become what? So let me write it here. What this condition C will become. So for this tuple, the condition C will become true. For this tuple, the condition C will become true. For this also true. For this also true. Okay, for all of them, this will become true. But now here something interesting will happen. When A is null, put A equal to null. When A value is null, then what will happen? When A value is null, then null less than equal to 0. This is comparison or what? Null greater than 0. See, null less than 0. This is comparison. So the result will be unknown. This is comparison. So result will be unknown. What is unknown or unknown? What is unknown or unknown? Unknown or unknown? That also will be unknown. Okay, yes or no? So remember, for this tuple, the selection condition, the tuple selection condition, this condition number C, this will become unknown. For this also it will become unknown. Okay, so which tuple will pass? Only these four tuples will pass. Okay, yes or no? These tuples will fail. Simple. So the number of tuples in the output, that will be four tuples in output. Is this clear? Okay, so the question is asking number of tuples in the output. The answer will be 4. This is the answer. Let's move on now. You can read this. The same thing is written here. You can read this. Okay. You can easily see this is your table X. Means this is the attribute X. Now tell me how many tuples this query will give you. What is the result of this query? This is your attribute X. What is the result of this query? Where X is greater than 0. So this will, for this tuple, this condition will be true. For this tuple, this condition will be true. For this tuple, this condition will be unknown. So these two tuples will pass, and this will fail. You can see this will be the answer. Similarly, if you have this query, again the same thing. For this tuple, this condition will be true. For this tuple, this condition will be true. For this tuple, this condition will be unknown. So sorry, for these, this condition will be false. Sorry, for these, this condition will be false. False. Okay. And for this condition will be unknown. So all of them will fail. So that is the reason you can see empty table you are getting. Yes or no? You are getting empty table. So that's it. I hope you understood. Now let's move on. Now let's see SQL keywords, that is null, is not null. These two keywords we need to study. So let's see. Now let's assume you have a relation with a single integer attribute A. Okay. Assume we want to know how many null values are there in the column A. This is what we want to know, right? Yes or no? In this A column, how many null values are there? We want to find how many null values are there. This is what we want to find. Okay. Assume we want to know how many null values are there in the column A. Is this query correct? Please tell me. Can I write like this, that from this R, where A is equal to null? Can I do this? Where A is equal to null? Is this query correct? The answer is no. This query is not correct. Okay, this query, let me tell you, this query is invalid. This is illegal, or I can say invalid query. Why this is invalid query? Because remember, because we cannot use null as a operand. This is invalid query, remember. This is invalid query because this query will give you error. This is invalid query because SQL does not allow null as a operand. We cannot use we cannot use null as a operand, as a direct operand. Is this clear? We cannot use null as a operand in the query. In the query. Okay, is this clear? So very simple. You are saying that A equal to null. Actually, we cannot do that because basically what you are doing, you are using this null as a operand. It's like, for example, if I put 5, then this is fine. Then it is fine because this is constant. Okay, this is operand, but this is not fine. Okay, you cannot use null as a operand. Is this clear? This is invalid query. Don't think some students are saying the result will be empty table. Some students are saying result will be empty table. No, this is invalid query. This will give you error. This is an illegal SQL query. This query itself is invalid. SQL says we cannot use null explicitly as an operand. Okay. So SQL gives you two facilities. Okay, to check null. To check null. To check null value. Remember, if you want to check null value, then SQL gives you two facilities. Then SQL keywords are there. This is what you can use. Okay, you can use SQL keyword that is null, or you can use this keyword is not null. Okay, is this clear? So these special facilities are given by SQL. These are special facilities. These are SQL keywords is null, is not null. This is what you can use. Okay, is this clear? Please tell me. You can use this keyword or you can use this keyword. These facilities you can use to check null, but you cannot use null as a operand. This null you cannot use as a operand in the SQL query. In the SQL query, this null cannot be used as a operand. So you can see SQL says we cannot use null explicitly as an operand. Okay, so what you can do? This query is fine. Yes or no is null. Is this clear? So this is the correct query. I hope you understood. This query will give you how many null values are there in the column A. From the table R, how many tuples have null value in the column A? That will be your answer. For example, if your table R has, let's assume this is your table R, A, and you have, for example, let's assume 0, null, -1, null, and 2. Let's assume this is what you have, or maybe again 0. Let's assume this is what you have. So tell me, in this query, output will have how many tuples? Number of tuples in output, what that will be? Number of tuples in the output, that will be. So remember, you can see A is null. So these tuples will pass. Yes or no? Do you agree? This tuple will pass the where. This is the tuple selection condition. Again, this is tuple selection condition. This is a tuple selection condition. Okay, so this tuple will pass. this tuple will pass. These two tuples will pass. This tuple will fail. Yes or no? So finally, your answer will be number of tuples, that will be 2. Is this clear? Please tell me. So SQL has this facility. SQL provides you this facility. Is null, is not null, if you want to check null value. Okay. Now similarly, tell me about this. Is not null. This will give you how many non-null values are there. Yes or no? How many non-null values are there? So for that you can use is not null. Very simple. So like this you can do. Okay. In this case, what will happen? If you have table R and this is your A, let's assume 0, null, 0, null, -1. Okay. Then in this situation, remember, this will fail. This will fail. All the remaining will pass. All the non-null values will pass. So this is what will happen. Okay. And you know the count star. The count star will count the number of rows. Yes or no? This will always count the number of rows. Do you agree? This will always count the number of rows, that you already know. Okay. Number of rows. This will count number of rows. But remember, first where clause will apply. Remember, please understand. First this will happen, conceptual evaluation, then this will happen, then this will happen. Right? Yes or no? Is this clear? Please tell me. Okay. Then this will happen. In the conceptual evaluation, first from clause, then where clause, then this last clause. Okay. Is this clear? So for this question, the answer for this query, how many tuples in the output? Number of tuples in output, what that will be? That will be number of tuples in the output, that will be 3. Okay, clear? Let me know. So very simple. Okay, the same thing in the previous query. In the previous query, remember this count star, this will count the number of rows. Yes or no? First this will happen, then this will happen, then this will happen. Correct? Okay, so remember this count star will count the number of tuples. But first where clause will happen. Yes or no? Is this clear? Let me know. So let me ask you one more variation. You tell me about this one. From R. From R, where? Where A is null. Select. Select. Count A. Okay. Is this clear? Now you tell me, if I give you this table, I am giving you this table, I am giving you this table R, and this is the attribute A. And let's assume you have this table null, 0, null, 0, -1, null. Now tell me the answer. Let me know. Okay, so very simple. What will be the answer? This is what I'm asking. Number of tuples in the output. Simple question. Or I can say, what is the output? You just tell me that. Okay, what is the output? You give me the output itself. Okay, you give me the output itself. Give me the output. So, very simple point. Remember, first, what will happen? First, in the conceptual evaluation, first this will happen. Then, second, this will happen. Okay, so what will happen is null. So, very simple. This will fail. This tuple will fail. This tuple will fail. This tuple will fail. Correct. This tuple will pass. This tuple will pass. This tuple will pass. Okay. Now the third thing will happen is this. This is the third thing. Count of A. So what that will be? So the output will be this count of A. So you can see only these tuples are passing. Okay. Null, null, null. So this will ignore the null values. This count will ignore the null values. It will ignore all the null values. You will get the empty table. Okay, for empty table, this count A, this will be 0. So your output will be this. If I ask you number of tuples in the output, what there will be? If I ask you number of tuples in output, What that will be? Number of tuples in the output. The answer will be 1. This is a tuple, right? Yes or no? See, this is a tuple. The tuple value is 0, but this is a tuple. So number of tuples in the output, that will be 1. Is this clear to everyone? Please tell me. Okay, so very simple. Remember the conceptual evaluation. Always follow the conceptual evaluation. First, from clause will happen, then where clause, then select clause. Okay, always follow the conceptual evaluation. Now let's move on. So we have seen all these points. Now let's see some questions based on the concepts that we have already seen. Let's see some questions. Now, tell me the answer for this question. You can see here C is an integer. Okay. And you can see we permit the null values. Choose the statement below that describes the result of this SQL query. This SQL query is given to you. Now, what will be the answer? You can easily see. See this condition. Look at this condition and tell me for which tuple this condition will be true. For which tuple this condition will be true. This condition becomes true. Okay, yes or no? This condition becomes true. This condition is true if and only if null values. If and only if, okay, for all C equal to null values. Yes or no? I can say this condition is true for all non-null values of C. Correct? Yes or no? Okay. And for null values of C, this will happen what? For null values of C, it becomes unknown. It becomes unknown. Okay. So finally, I can say that you will get select star means you are getting all attributes. We are getting all attributes. Okay. So all rows where C is non-null. Okay. All tuples where C is not null. These tuples will satisfy. So the answer will be option D. Is this clear? Very simple question. Tell me the answer for this question. This type of question has come in the GATE exam in 2004, I think. This type of question has come where they are asking you to assume something. See, we already know that SQL does not allow null to be explicitly used as an operand. That we already know, right? SQL does not allow null as an operand in the SQL query. That you already know. So the following query is invalid. Do you agree the following query is invalid? Yes or no? This following query, A equal to null, this is invalid, illegal. But for this question, okay, only for this question, assume that null value can be used as operand. Okay, just assume for this question, assume that null value can be used as operand, means assume this is not, this is legal, assume this is valid query. Then how many tuples will be there in the output? How many tuples will be there in the output? Let me tell you the this column A. Okay, let me give you the column A. So let me give you, for example, 20, null, null, 0, 0. Okay, now you tell me. So how many tuples will be there in the output? Assume this query is valid. Assume this query is valid. Just for this question. Actually, this query is invalid. You already know. This query is illegal. But for this question, assume that this query is fine. Now you tell me. So what will be the answer? So remember, let me tell you, this type of question has come in the GATE exam in GATE 2002 or GATE 2004, where they are assuming something which is not in SQL. In this question, we are assuming something which is not allowed by SQL. Similarly, in a GATE exam question, they were asking to assume something which is not allowed in SQL. Okay, this type of question has come in the GATE exam. That is the reason I am taking this question. So you tell me the answer. So you can see first, this will happen. You already know. In the conceptual evaluation, first this will happen. So this is your table R. Then second, what will happen? Second, this where will happen. Second, this where will happen. Now you tell me, for every tuple you will check. For every tuple, it is checked. Okay, for every tuple it is checked. So let's check it for every tuple. Okay, so you tell me for this tuple, the this condition, you tell me about the condition a equal to null. What about this condition? You tell me what this condition will become. For this tuple, this is a comparison or not? Is this a comparison? Yes, this is a comparison, right? Okay, a equal to null. This is comparison. This is comparison with null. So for this tuple, this condition will become unknown. For this unknown, for this unknown, for this unknown, for this unknown. So all the tuples will fail. Yes or no? All the tuples they fail. Okay, so for this question, the answer will be how many tuples in the output? Answer will be 0. Is this clear? Please tell me. Number of tuples in the output, that will be 0. Is this clear to everyone? Because all the tuples will fail. So now do you understand why we cannot use null as a operand? Now did you understand why null cannot be used as a operand? Is this clear? Why we cannot write a equal to null? Now did you understand why SQL does not allow null as a operand? Did you understand? Let me know. Okay, so very simple point. Let's solve this question. SQL aggregate function that gives the number of rows containing non-null values for a given column. Which aggregate function gives the number of rows containing non-null values for a given column? So you can see the answer will be count. Okay, so this is a simple question. Let's see this question. Which aggregate function returns count of all null values returned by a value expression? So can I say count star or count? So the answer will be this. Yes or no? This will not ignore null values. Yes or no? This won't ignore null values. This doesn't ignore null values. This doesn't ignore null values. Let's move on. Tell me the answer for this. Which is not an aggregate function? Which of them is not an aggregate function? So you can see this average, this is not aggregate function. Yes or no? All these are aggregate functions. Or these are SQL aggregate functions. Okay. So very simple. Tell me the answer for this. Which aggregate function does not ignore null values? The answer will be count star. Count star does not ignore null values. Tell me the answer for this. All these questions I found in some university assignment or on the check website. Okay, so you can see all of them except who ignores the null values. So the answer for this question, answer will be option B. You can read the question. Answer will be option B. Okay, all of them will ignore the null values except count star. Now let's see the next topic, that is the definition of duplicate tuples in case of null values. In case of null values, what is the definition of duplicate tuples? When can you say that a tuple is duplicate? See, let me give you one example. Let's assume you have this A, B. These are the two attributes. Okay, some tuples I am giving you. You tell me. For example, 1, 2, 1, 2. Are they duplicate? Are they duplicate? Okay, now let me ask you something interesting. This null, 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 null. Are they duplicate? Let me ask you another interesting. 1 null, 1 null. Are they duplicate? Null 1. Okay, so which of them are duplicates? See, I want to tell you the definition of duplicate tuples in case of null values. In case of null values, what is the definition of duplicate tuples? So tell me, are they duplicate? Yes, they are duplicate, right? Okay, there is nothing here. They are duplicate tuples. Okay, what about the next one? What about these two? Are they duplicate? Will you consider them duplicate? Are they duplicate? The answer is yes, they are also duplicate tuples. Okay, they are also duplicate tuples. See, let me tell you that the definition is like this. The definition of duplicate tuples, the definition of duplicate tuples is like this, that you can understand like this, that from the human eyes, see, from the human eyes, what is looking duplicate, that is duplicate. You can understand like this. Is this clear? See, this is the definition of duplicate tuples. You can see the definition of duplicate tuple is very simple. The SQL definition of duplicate tuples. I am telling you the SQL definition of duplicate tuples. Students are asking why null value. See, this is an exception. Read this. This is an exception. Okay, this screenshot is taken from Korth or Navate. You can check it out. Either Korth or Navate. I am telling you the definition of duplicate tuples. Okay, this is an exception. Is this clear? You can say this is anomaly. What you are thinking is written here. There is a contrast. Yes or no? Null equal to null, that is unknown. Null equal to null is unknown. Yes or no? That is written here in this book. That if you compare two null values, then result will be unknown. But in the context of duplicates, you will consider them as duplicates. Is this clear? Please tell me. What you are thinking, that is already written here. I understand your feelings. But I am just telling you the definition of duplicate tuples in case of null values. Okay, so this is the definition, the SQL definition of duplicate tuple, that is two rows are duplicates if the corresponding columns are either equal or they both contain null. Read the definition. The SQL definition of duplicate tuples. When can you consider tuples as duplicate? So, two tuples are duplicate. Let me do it here like this. That two tuples are duplicate if the corresponding column values are either equal or they both contain null. Okay, is this clear? So very simple words. Okay, you can do like this. See, duplicate tuples means if they are looking duplicate to human eyes. Like this, you can understand. Duplicate tuples means if without thinking too much, they are looking duplicate. Okay, to human eyes, they look duplicate. Is this clear? You can understand. This is a trick. You can take this trick that to human eyes, they look duplicate. Okay, the definition is very simple. The corresponding columns must be equal or they must contain null. So remember, these are duplicate tuples. Similarly, these are duplicate tuples. These two are duplicate tuples. What about the last two? What about the last two? What about these? Are they duplicate? Please tell me. What about these? They are not duplicate, right? They are clearly not duplicate. Okay, so that's it. This is the definition of duplicate tuples. Is this clear to everyone? Please tell me. This is the definition of duplicate tuple, SQL definition of duplicate tuple. Now, what type of questions they can ask you? For example, see, they can ask you this type of questions. Select distinct. Select distinct star from R. Okay, from relation R, select distinct star. Now, let's assume that this relation R has these tuples A, B, null, null, 1, 2, 1, 2, and 1 null. Now, tell me the answer. Let me know. So, here what will be the answer? So, number of tuples in the output will be 3. Okay, is this clear? So, this is the definition of duplicate tuples in case of SQL. So, we have seen all these points. Let's move on now. So far, did you understand everything? Please tell me. Did you understand null values? We have seen all about null values. Every concept related to null values we have seen. every variation related to null values, any tricky question related to null values. So did you understand the null values? Let me know. So very simple. Now let's move on. Now, now we will study the new clauses in the SQL, that is group by clause and having clause. These two new clause we will study now. First, we will study group by clause. What is this group by? The name itself is telling you group by. Okay, you are grouping based on some attribute value. You are making group based on some attribute. Okay, so this is the name group by. Let me tell you the syntax. The syntax is like this. First you will write select, then you will write from, then you will write where, and then you will write group by list of attributes. This is the syntax. Is this clear? So remember, we are studying the new clause, the new SQL clause. So far we have seen, select from where. Now we study group by. So remember, this is the syntax. First you will write select. In the select you will write attribute names. Then from here you will write the table names. Here you will write the where. Here you will write the tuple selection condition. And then you will write the group by list of attributes. The name itself is telling you group by, means you are making groups by attributes. Okay, so group by attribute names. For example, you are making group based on ages. Yes or no? So tell me intuitively, you tell me what will happen. From student table, you are making group based on ages. You are making groups based on ages. Intuitively, what will happen? Intuitively, you can think like this, that all the people, all the tuples with same age, they are in one group. All the tuples with same age, they are in one group, like this. Like this, groups will be created. Yes or no? All the people, all the students who have same age, they are in a group. All the students who have same age, they are in the same group. Okay, so this is very intuitive concept. Let me tell you. Yes, cluster. Okay, you can understand like this, that clusters will be created. Clusters. Okay, so all the students who have age 20, they are in the same group. All the students who have age 25, they are in the same group, like this. So based on the age, clusters, or I can say groups, will be created. So the name itself is telling you group by. You are creating groups based on age. Based on the age, the groups will be created. Okay, the tuples will be divided into groups. Okay, is this clear? Very simple. So this group by, this is the most intuitive concept, let me tell you, because the name itself is telling you what will happen. So now let me tell you that what is the usefulness of group by. Usefulness of group by. So you are making group, and then what is the usefulness? Why you are making group? See, this is the question that you should ask. Sir, why are we making group? This group by is making group, that is fine, but why we are making group? So the answer is to get group by summary. For each group we want to get a summary. Okay, very simple point. Read this. Usefulness of group by clause. The group by clause will give you groups. It will give you groups. But why we are creating groups? What is the reason to create groups? Because we want group wise summary. Group wise summary means, for example, for each group, I want what is the average. What is the average of this group? What is the average of this group? What is the average of this group? So I want group wise summary. Summary means aggregation. Yes or no? Summary means aggregation, that you already know. Aggregation means summary, summary means aggregation. So I hope this point is clear, that remember, group by will create groups. For example, these are the people who have age 20. These are the people who have age 20. These are the people who have age 25. Okay, and let's assume these are the people who have age 40. Okay, so these are the groups we created. But why we are creating the groups? I'm answering this question. What is the usefulness of creating the group? Why we are creating groups? To get group wise summary. We want to get group wise summary. For example, I want average age of each group. For this age, for this group, what is the average? For this, what is the average? For this, what is the average? Or I can say, for this, what is the maximum age? For this, what is the maximum age? Actually, not maximum age, because age is 25. I can say, for this group, what is the, I can say, what are the maximum marks? Okay, in this group, what is the maximum marks? In this group, what is the maximum marks? So like that. I hope you understood the point. So group by clause, we are creating groups so that we can get group wise summary. Summary means aggregation. We want to apply the aggregate function on each group. On every group, we want to apply aggregation function. Read this. Consider this query. We are creating group based on ages. Yes or no? Based on ages, groups will be created. Then what we are doing? For each age, for each age group, we are creating the average of GPA. For these people, what is the average of GPA? For these people, what is the average of GPA? For them, what is the average of GPA? Like this. Is this clear? For each group, we are finding the aggregate function. For each group, we are finding the summary. I hope this point is clear. For example, look at this. Consider the relation student ID, name, state, marks. This is the student table. Now, read this query and tell me what comes to your mind. When you read this query, what will come to your mind? Find the average marks of all students state wise. Means for each state, find the average marks. For every state, find the average marks. So tell me, you will create the group based on what? Let me know. You read this query and tell me, you will create the group based on what? Yes, based on state, very simple. See, for each state, I want average marks. Okay, so what I will do, very simple. From this table, from this students table, okay, what I will do, I will create group by. First of all, do I need where clause in this query? Do I need to remove some tuples? Do I need to filter some tuples? No. Okay, so where clause is not required. Okay, so from students, what I will do, I will do group by. I will create group. Group by what? Group by state. Yes or no? Because for each state, this tells you grouping. Okay, this is the phrase for grouping. This is the phrase for grouping. This is giving you the idea of grouping, that for each state means this is the phrase for grouping. We are creating group based on ages, based on state, for each state. Now, what this will do? This will create groups based on state. This is the group of Rajasthan, this is the group of Tamil Nadu, this is the group of Maharashtra, and so on. Okay, is this clear? So, based on state, groups are created. Then what we will do? We will select, we will output. What we will output? For each state, we want average marks. For each group, we want average of marks. Is this clear? Yes or no? For each state, what are the average marks? For each group, what is the average marks? Tell me one thing. For one group, how many tuples will be there in the output? For one group, like this is the group of Maharashtra. Okay, these are the students of Maharashtra. For them, I want average marks. So for one group, how many tuples will be there in the output? In the output, you will have Maharashtra, average marks of Maharashtra. So for one group, one tuple. For one group, one tuple in the output. Is this clear? Very intuitive concept, right? I'm telling you, this group by clause is very intuitive. Okay. And one thing I want to tell you, this is a trick, that when to create, basically for which attribute to create groups. Okay, how to find? Okay, so for which attribute we want to create? For which attribute we need to create group? How to know? For which attribute we need to create groups? How to know? The answer is this phrase, to each something something something, then something something something. Okay, to each state, for example, to each state or for each state. Yes or no? So I can say for each. Okay, for each. So this for each, and if you are writing a, then something something something, it simply means that you will create group based on a. Yes or no? So the answer, this phrase will tell you that we need to create group based on a. Is this clear? So create group. So group by a, I can simply say, so group by a. Is this clear? Let me know. I am saying that, read this question. In this question, you can easily see, for each state, I want something. For each state, I want some data. Okay, for each state, I want a summary. So it means I will do the grouping based on state. Okay, yes or no? Based on state, I will do the grouping. So this is what I'm telling you. For which attribute we need to create the groups. How to know? This phrase will help you. For each a something something something. So you group by a. Okay, this is just a guideline. Understood? Did you understand this guideline? Okay, let's move on now. So very simple point. We need to create groups. We need to create. Okay. So state wise we will do the grouping, and for each group we will find the summary. Means for each group we will find the average marks. Average marks means summary. Okay. This is aggregate. You can call it aggregate or you can call it summary. So very simple. Now let's move on. So usefulness of group by, that is group by group wise summary. Okay. For every group we want summary. So what I can say, for every group how many tuples? So for every group one tuple in the output. Is this clear? One tuple in the output. For every group we will get one tuple in the output. Okay. Actually, let me tell you, when we study having clause, when no having clause. Okay. This will happen when you have no having clause. Don't worry, we will study having clause. Actually, what having clause will do? Having clause will remove some groups. See, we will create groups. First, we will create groups. Then having clause will remove some groups. Okay. But remember, for the remaining groups, one tuple for each remaining group. Is this clear? One tuple for each remaining group. I can say, so when no having clause. Okay, actually, there is something called having clause. This we will study, don't worry. Having clause we will study. What is the work of having clause? This having clause will filter some groups. Means first you will create groups, then some groups will be removed by this having clause. For the remaining groups, one tuple will be in the output. Okay, for the remaining groups, there will be one tuple in the output. So far we will not consider having clause. So assume there is no having clause, then for every group, one tuple in the output. Okay, because we are doing group wise summary, group wise aggregation. Easy concept. Now let's move on. Now, first let's understand what grouping means. For example, this is your table R. Now, if I say group by A, then what it means? Tell me, will it happen that all these all these tuples will actually shuffle? Will it happen? See, I'm asking, when I say group by A, then will it happen? Then will it happen that all the tuples will shift? Like all the tuples, they will exchange their place, or I can say, okay, yes or no? Will they shift? No, they are not shifting. Remember, actually, see, group by A, this will give you a virtual partition. Okay, this is a virtual grouping. Remember, actually, the grouping will not happen. This is just a virtual grouping. For our understanding, this group by A, this is virtual grouping of tuples. Is this clear? There will be imaginary grouping of tuples. Means whenever you are solving any question, you can do this type of virtual grouping. Okay, like this. For example, group by A, we are doing grouping by A. So you can see here A value is same. Okay, so these tuples in one group. Okay, and this tuple in another group. So how many groups will be created? Okay, yes or no? How many groups? G1, G2. Two groups will be created. But remember, this is just a virtual grouping. Is this clear? This is just a imaginary grouping. Two groups will be created. Imaginary two groups are created. I can say like this. It is a imaginary grouping. Imaginary grouping. Okay. For understanding, you can understand like this, that all these tuples in one group, all these tuples in one group. Because we are grouping by A. Based on A, we are grouping. So these are in one group and this is in another group. So two groups will be created. Okay. Is this clear? Very simple. For example, here, how many groups will be created? Just tell me this. Imaginary grouping of tuples. So tell me, group by A comma B, how many groups will be created? Let me know. I am grouping based on A comma B. How many groups are created? Very simple. Here AB is same, AB is same, AB is same. So they will be in the same group. 1, 2, 1, 2, 1, 2. They are in the same group. Okay, and this tuple in another group. So again, there will be two groups. Okay, is this clear? If I say group by B, then how many groups will be created? If I say group by B, based on B you are grouping, then again two groups will be created. Okay, then again two groups will be created. You can see we are doing grouping based on B. Then again two groups are created. You can see these are same B values, so they will go in the same group. 1 2 1 2 1 2 and 3 4. Again two groups are created if I do grouping based on B. Okay, let's move on. So you can see, again I'm telling you, relation with imaginary division of groups. See, for example, studio name. If I do grouping based on studio name, means my query is this: group by studio name. Group by studio name. Okay, if I write like this, group by studio name, then what will happen? You can understand like this, that where studio name is same, those tuples are in the one group. So this group will be created. This is G1, this is G2, and so on. Okay, is this clear? So like this grouping will happen. This is just a imaginary grouping. To solve the question, you can create group like this, but it does not mean that tuples will shuffle. Okay, the tuples, the rows, they will exchange places. It will not happen. It is just a imaginary grouping. Okay, we are not doing ordering. Like for example, we are not sorting. Yes or no? We are not sorting that. Okay, these tuples will come first, then these tuples will come. No, we are not sorting. This is just a imaginary grouping. Okay, for solving the question, you can think like this, that these are in one group, these are in one group, and so on. Because we are creating group based on studio name. Okay. So all the studio names where Disney is there, studio name equal to Disney, these tuples in one group, these tuples in another group. So like this groups will be created. Okay. Tell me here, if I do group by C, how many groups will be there? Just tell me how many groups. If I do group by C, how many groups will be there? Just tell me that. So you can see group by C. I am grouping by C. C values are different. So four groups will be there. Okay. Four groups will be created. Very simple. Okay. If I say, for example, group by BC or maybe AC, group by AC. Now you tell me the answer. Group by AC. Group by AC. Now how many tuples? How many groups? Group by AC. So you can see AC. Look at AC. 1 5 3 6 1 7 1 8. All are different. So four groups will be created. Okay, very simple. Group by AB, how many groups will be created in this tuple? Group by AB, 1 2 1 2 1 2. So they will be in one group, and this will be in another group. So it will happen like this, that ABC. Okay, see, this group will be created where you have 1 to 5, 1 to 7, and 1 to 8. This will be group number 1. Okay, this numbering I am giving, this is not the actual numbering. Okay, this is just for my convenience. I am giving this numbering. Okay, don't worry that, don't think that okay, this will be group number 1. No, 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 there is no group number 1. There is no group number 1, there is no group number 2. Okay, this is just for understanding, this is just for our understanding. This is just imaginary grouping. Okay, so you can think like this. And another group will be like this. Another group will have, okay, so this you can say G2. So two groups will be created, and so on. If I do group by ABC, how many groups will be created? Then four groups will be created. This in different, this different, this different, this different. So four groups will be created. Okay, very simple. Now let's move on. Okay. Now let me tell you about null values. If you have null values, then how you will do the grouping? Okay, for example, let me give you a table R, and in which there are two attributes A, B. Let me give you some, for example, 2 5, 2 5, 2 null, 2 null, null null, null null. Okay, like this. So let's assume you have this, and maybe null 3. Okay, so you have this table. Is this clear? Now you tell me how many groups will be there if I say group by A. If I say group by A, how many groups will be created? If I say group by A, see, here a value is same, so this will be one group. Okay, yes or no? This will be one group. And actually, for all the null values, there will be one group. Okay, for all the null values, there will be one group. So let me tell you the rule about null values. When you have null values, then to create grouping, when you are creating a group, treat this null value as a normal value. To create the group, remember, null is treated as ordinary value when forming the groups. When you are forming the groups, then null value is treated like a ordinary value. Or I can say that all the tuples with null value will create one group. All tuples with null value will create one group. So you can see, if I say group by A, then what will happen? If I say group by A, then one group will be created. This is one group will be created. Okay, so in this situation, this will be one group, and the remaining these will be in one group. Okay, because I am doing grouping by A. So you can see here A value is same. So these tuples in group 1, and here A value is null. So these tuples in one group. So two groups will be created. If I say grouping by B, now tell me, grouping by B, how many groups? You can see here B value is same. So one group is this. Okay, so this will be, because B value is same, right? 5, 5. So this will be one group, G1. Okay, this will be another group. Here B value is null. Okay, so this will be G2, and this will be another group. This will be G3. So three groups will be created. Is this clear? So the null values in case of grouping, did you understand? In case of null values, how to make group? Did you understand? Let me know. Very simple. If I say group by A comma B, now how many groups will be created? A comma B. See here A comma B values are same. So this is one group. Okay, here this is your one group. Another group will be 2 null, 2 null. This is another group. Okay. Next, another group will be null, null. This will be another group, and null comma 3, that is another group. Okay, so for this, four groups will be created. So very simple. Now let's move on. Now let's see SQL query template in case of group by. When you have group by, then what is the query template? Okay, understand this query template. So the query template is like this. You will have select comma from, where those things you will have. From will be there. Yes or no? You already know from will be there. Where will be there. Okay. Where is optional, right? That you already know where is optional. Select comma from, they are mandatory. Select is there, and group by is there. First of all, this is the syntax. First you will write in this order. You will write first, you will write select, then you will write from, then you will write where, then group by, and so on. If there is no where, then you can write select from group by. This is optional, this is also optional, these are mandatory. Okay, now one important thing I want to tell you, here you will write only attribute names. Okay, remember, in the group by, you can only write attribute names. For example, group by A1, A2. Okay, group by A1, A2, A3. Let's assume these are the attributes. Group by A1, A2, A3. Now let me tell you something interesting, that if you are grouping by A1, A2, A3, then this A1, A2, A3 must come here unaggregated. As it is, this must come. A1, A2, A3 must be here unaggregated. These are here, these are here. Okay, but in the select clause, you cannot put anything else. This you cannot put. Okay, you cannot put any other unaggregated attribute. So these attributes, they must be same. In the group by, we have column names. See, you already know that in the group by, here we have column names. Actually, the template is like this. Group by, here you will have column names, or I can say attribute names. Or I can say attribute list. Yes or no? Here you will have attribute list. Okay, unaggregated. You cannot put aggregation here. For example, group by AVG of A. Does it make sense? Group by AVG of A. Does it make sense? Group by AVG of A. No, that does not make sense. Okay, so remember, here you have attribute list. Okay, this same attribute list, let's call it, this same attribute list will come here. Let's call this attribute list L. This same attribute list will come here, L. Okay, this will come here, and there will be aggregation, and you can put aggregation. Aggregation you can put multiple times, no problem. Okay, so remember these attributes will come here as it is, and there can be aggregation. So this is what I'm saying. If you have a1 a2 a3 here, then you have a1 a2 a3 here. You cannot put a4. If you want to put a4, then you need to put aggregation. So aggregation you can put, for example, you can put, like, for example, you can put summation. You can put summation based on a4, no problem. Aggregation you can put on anything. For example, you can put count. You can put count on a1, no problem. Is this clear? So aggregation you can put on any attribute. You can put aggregation on any attribute. You can also put count star if you want. There is also no problem. You can put count star. Okay, is this clear? Please tell me. So I hope this point is clear. So remember, you cannot do this, that here you have these attributes and here you have a4. Okay, and let's assume you have avg of some attribute. Now this is not allowed. Okay, because this is not allowed. Is this clear? This is not allowed. Please tell me, did you understand? Let me know. Is this clear? Also, what is not allowed? Let me tell you also what is not allowed. For example, for example, here you have a1, a2, a3, and let's assume here you only have a1, a2. Okay, here you have a1, a2, a3, and let's assume you have like this. Okay, this, and let's assume count based on a4. That is fine. Aggregation is fine. Okay, aggregation is fine. But remember, here you have a1, a2, a3. Here you don't have. Maybe let's assume c c c c. Now, can I say this is allowed? Can I say this is allowed? No, 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 no. These must be as it is, unaggregated. Unaggregated. Okay, so remember, this is also not allowed, because here you have a1, a2, a3, here you have a1, a2. So this is also not allowed. Actually, this is not allowed in SQL 92, which we will follow for the GATE exam. This is not allowed in SQL 92 standard. Okay, in SQL 92 standard, this is not allowed. In other standard, this is allowed. In SQL 99, this is allowed. Okay, is this clear? But from the GATE exam point of view, always follow SQL 92, because all the standard books, they are based on SQL 92. All the standard books, Ullman, Raghurama Krishna, Nawate, Korth, all of them, they are based on SQL 92. In SQL 99, this is allowed. Okay, but this is not allowed in SQL 92. From the GATE exam point of view, stick to SQL 92, because all the standard books, they are based on SQL 92. So if you stick to SQL 92, your answer will not be wrong. Okay, yes or no? So very simple. Now let me tell you. So is this clear, that you cannot put extra attribute in select clause? You cannot put extra unaggregated attribute. Extra unaggregated attribute you cannot put. This is not allowed in any SQL. Actually, this is not allowed in any SQL standard. Okay, and one more thing, if you have a1, a2, a3 here, but here you are putting a1, a2, you are not putting a3 directly. You are not putting a3 directly. This is not allowed in SQL 92. So what is the conclusion then? You don't have to, think too much. Okay, just follow this. This follow. Okay, this is this template you follow. Is this clear? That if you have a1, a2, a3 here, then a1, a2, a3 here, and aggregation you can do on anything. You can do aggregation on anything. So this is the template you can follow. Is this clear? You can see this is from the standard resource. This template is given from this university. Group by B1, BK. So this B1, BK must be here. Okay. Aggregation you can do on anything. It doesn't matter. Is this clear? Let me know. So very simple. This B1, BK is here. This B1, BK is here. Okay. Aggregation you can do on any attribute. Aggregation you can do on any attribute. Now what this means? What this as means? This is just a renaming. This is just a renaming. Okay, this is just renaming. You are renaming that. Okay, in the output, this aggregation you will write as x1. Okay, so the output will look like this. Your output will look like this. In the output, you will have b1, b2, bk. Okay, this aggregation is renamed as x1. Okay, and so on. This aggregation is renamed as xm. So this will be your output. So remember, this is just renaming. Is this clear? Anyone has any doubt? Let me know. Please tell me. So is this clear? Let me know. I'm giving you the conclusion. Remember, I'm giving you again the conclusion. I will give you. Don't worry. So far, you understand. I know. Again, I will tell you the conclusion. But let me tell you the conceptual evaluation when you have group by. Then what is the conceptual evaluation? So remember, this is the syntax. This is the syntax. First, you will write select, then from, then where, then group by. This is the syntax. In this order, you will write. This is the syntax. Okay, this is the syntax. Now, what is the semantic? What is the conceptual evaluation? This is a conceptual evaluation, right? Is this the actual evaluation? Tell me. Is this actual evaluation? No, this is just a conceptual evaluation for our understanding. The evaluation. The DBMS will not execute like this. I told you in the last lecture that this is just a conceptual evaluation. DBMS will not execute like this. This is just for our understanding. So remember, first you do from, then you do where. Okay, first you do the cross product of these tables, the from. These tables you do the cross product. Then you filter the tuples, okay, based on the tuple selection condition. Then you make the group. After making group, you output the select. Okay, is this clear? So first, then second, then third, and select is fourth. I hope this point is clear. So this is the conceptual evaluation. I hope you understood. One more thing, the aggregation will always happen within the groups. Okay, see, you already have this template, right? The template is like this, that the group by, if I'm grouping by, let's assume a comma b. Okay, I'm grouping by this. Then in the select, this a comma b must come as it is, right? Unaggregated. This a comma b must come as it is. Okay, you have from something 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 where something something something. Okay, so now remember, this a comma b must be coming as it is. This aggregation you can do for anything. For example, you can do sum of a, you can do min of c. Okay, you can do count star. So aggregation you can do on anything. One thing I want to tell you, this aggregation will happen group wise. Okay, this aggregation will happen group wise. Happens group wise. Okay, is this clear? So if there is no having clause, then for every group one tuple will be there. Okay, is this clear? So remember, aggregation will happen group wise. For every group, aggregation will happen. This is the one point. And when there is no having clause, then number of tuples in the output, that will be what? So let me write it here. This is a note. When there is no having clause, then what will be the answer? When no having clause, then for every group one tuple in output. For every group one tuple in output. Okay, for every group one tuple in output. Also, so I can say, so number of tuples in output, that will be what? So number of tuples in output, that will be equal to number of groups. Number of groups. But here one thing you have to take care. Before creating the group, will you apply the tuple selection condition? Will you apply the where or not? Before creating groups, will you apply the where clause or not? Yes, of course. First you will apply where clause, then grouping will happen. Okay, so this actually I've seen some students making mistake. See, this is a very good result. Actually, let me tell you one thing. There are two gate question in which a big query is given. There is a question in gate 2019, another question I think gate 2021. Okay, you can check it. There are two gate question in which actually these are big questions. Both the questions are very big. Some details are given. Then query is given. Okay, then query is given, and the question is asking number of tuples. The question is asking number of tuples in output. Okay, is this clear? So here you have group by. Okay, in the query there is group by and there is no having. There is group by and there is no having. Okay, actually in this situation what you need to do? First you apply the where clause. First, of course, you have to apply the where clause. First you apply this where clause, then find how many groups are there. Find how many groups are there. Then you don't have to do anything. You don't have to see the select. You do not have to do anything. The answer will be number of groups. But first you apply the where clause. I told you in the conceptual evaluation, first we filter the tuples, then we find the number of groups. There are two gate questions, you can check it out. Okay, and those two gate questions you can very easily solve. This is the result. Number of tuples in the output is equal to number of groups when there is no having clause. Okay, so when there is no having clause, then for every group one tuple in the output, so I can say number of tuples in the output that is equal to number of groups. And there is a note here. Okay, before creating groups apply where clause. Yes or no? That you already know that before creating groups first we have to apply where clause. Before creating groups apply where clause. Don't forget about where clause. Okay, so that's it, very simple. So this result actually will help you. Okay, so now let's see this. This table R is given to you. If I do group by A, how many groups will be created? Please tell me. Forget about this. Forget about this. If I do group by A, then how many groups will be created? Group by A. See, group by A. So value of this is 1, this is 1, this is 1. So they will be in one group. Yes or no? You can assume that they are in group 1. Value 2, value 2. They are in group 2. Value 3 in group. This will come in group 3. Yes or no? So there will be three groups created. Agree? Okay, so you can see three groups are created. Okay, group by A. So three groups are created. This group, this group, this group. Yes or no? Okay. Now, if I select A count star max B, then what will be the answer? See, I have done the grouping by A. Now I am selecting A comma count star comma max B. For every group, one tuple will come. For this group, tuple will come. A value is 1. For this group, look at the first group only. For every group, one tuple will come. For this group, A value is 1, A value is 1. Count star, that is 3. For this group, aggregation will happen group wise. For every group, aggregation will happen. So for this group, count star is 3. And the max value is a C. What is the max value among A, B, C? Tell me, what is maximum in A, B, C? Lexicographic order. Okay, A is less than B is less than C. Lexicographic order. So maximum is C. Very simple. So you can apply the lexicographic order. So that's it. Very easily you can see that for every group, one tuple will be created. Is this clear? Next, what about this one? What about this? For this group, one tuple will be created. See, A value is 2. A value is 2. Count star is 2. And maximum value is B. What about this next one? For this group, value is 3. A value is 3. Okay, count star is 1 and maximum value is A. So did you notice that there is no having here? We do not have any having clause. So the number of tuples in the output, that is equal to number of groups. Agree? Is this clear? Please tell me. Very simple, right? I hope you understood. So you can easily see output will have one tuple per group. Okay, for every group, one tuple. Simple. Now let's move on. Now tell me the answer for this question. How many tuples in the output? we are doing grouping by a comma b. How many groups will be created? See, first you will do this from R. This is your table R. This is the table R. Okay. From R, then you will do this grouping by a comma b. So you can see AB, A1, B1, A1, B1. So they will be in one group. See, this will be in group pink group. Okay. They are in the same group. A1, B1, A1, B1. They are in the same group. This is also in the pink group. Yes or no? They are in the same group. Is this clear? I am doing virtual grouping. So you can say that I can say these are group number one. Okay, let's call it group number one. A to B1, A to B1, this A to B1, this is group number two, A to B1. So these two tuples in group number two. Okay, let me use some different color. So for example, you can see this tuple, also this tuple, A to B1, A to B1. They are in the group number two. Okay, and what is group number three? You can see this is group number three. Understood? Group number three. Tell me, is there any first group, second group, third group? Is there any concept of first group, second group, third group? Is there any concept? No. This is just virtual grouping we are doing for our convenience. I want to solve the question without any mistake, so I am doing this. Okay. There is no concept of first group, second group, third group. There is no such concept. I told you. This is just virtual grouping. Okay, now you tell me. We have done the grouping. Now select A comma B. You can see select A comma B. So remember, the aggregation will happen group wise. Okay, so the output will be like this. Let me tell you the output. The output will have total four columns. One column A, another column B, another column some C, and another column max D. So these will be the columns. Okay, now you tell me. So for each group, one tuple will come because there is no having. Yes or no? There is no having clause. So at this point, okay, just one thing I want to tell you. Once you have found the groups, now do you even care about this statement? See, there is no having clause. Please look at this. There is no having clause. Okay, there is no having clause. First, you do this, then there is no where. You don't have to filter the tuples. Then you create groups. You got three groups. You got three groups. Now, do you care about this first statement? Does it matter? This first statement, does it matter? Do you worry about first statement? Do you worry? No, forget about it. The answer will be three tuples, three groups, three tuples. When there is no having clause, then number of tuples in the output will be number of groups. So because there are three groups, so the answer will have three tuples. That's it. You don't have to write. You don't have to write the output. Is this clear? You do not have to write the output. You can simply say, if the question is asking number of tuples in output, that will be same as number of groups. The answer will be three. You don't have to worry about the first line. But anyway, let me tell you what will be the first line. Okay, just for understanding purpose, let me tell you. So for every group, one tuple will come. What is the tuple for G1 group? For G1 group, what the tuple will come? Tell me, for G1 group. For G1 group, A value is A1, B1. AB value, they are A1, B1. The summation C, that will be 1 plus 2 plus 6. That will be 9. Maximum D, that will be 12. This tuple will come. Next, tell me about the next. That is for G2. For G2, what will happen? You can see G2 has A to B1, value of A comma B, that is A to B1. Next, sum of C, that will be 8, 5 comma 3, that is 8. And max of D, that will be 11. Finally, you tell me about this last group, that is G3. Okay, so the value is A3, B2. The sum of C, that is 4. And the maximum, that is 10. Okay, max of D, that is 10. So you can see the aggregation is happening group wise. For every group, aggregation is happening. So this is your final output. Output has three tuples. Okay, yes or no? This is the final output. So number of tuples. in output, there is no having clause. So the number of tuples in the output, that will be number of groups, that is 3. Okay, for every group, one tuple. Is this clear? Group by clause is the most easy concept. Yes or no? Do you agree with me? It is very intuitive, right? Group by, this is very intuitive. You are creating groups, you are creating virtual groups. Very simple. This is a very simple concept. Let me tell you some more questions. Let me take number of tuples in the output. Now I will take the null values as well. Okay, I want to tell all the variations. So let me take, I'm giving you a table. In this table, let's assume you have these attributes A, B, C, three attributes. Okay, some values I am giving. For example, let's assume 2, 3 null, 2, 3 null. Let's assume null, null, null. I want to take all the variations, so I'm doing this. Of course, 2, 3, 4, 2, 4, 3, 3, 4, 2, 3, 4, 2, or maybe 3, 4, 1. So like this. Okay, some type of variations I want to take. So let me give you this table. Okay, let's see what variations we can create on this table. So first of all, let me do grouping by. You just tell me what question you want to answer. Like what? Just tell me which, for which question you want the answer. For which question? For example, if you do grouping by A, okay, from this table R, let me put the where condition also. The where condition is that where B value is not equal to 3, is not equal to 3. Okay, B value is not equal to 3. Select, in the select I have to put A, right? Yes or no? In the select I have to put A, that you already know. In the select we have to put A. Can I put B? Can I put B? No, that is invalid. I cannot put B. Okay, but I can put aggregate. Yes or no? I can put, for example, sum of B. I can put sum of B. I can put count of B. These things I can put. Okay, or maybe count of C. I can put that. Or maybe count of A. I can put that. That you already know. I can put count of A. Okay, now you tell me the answer. So this is your first question, number of tuples in the output. So first, what you will do? First, this is the table. Okay, this is the first step. The second step is this. This is the second step, remember. First step was this, and this is the second step. B is not equal to 3. B is not equal to 3. So tell me which tuple will satisfy? B is not equal to 3. B is not equal to 3. This is not equal to. This is not equal. And this is comparison. This is comparison. So tell me, for this tuple, this condition will be true or false? Here, this will be false. Here, this will be false. Here, unknown. Here, false. Here, true. Here, true. Here, true. So only these three tuples will pass. Yes or no? Only these three tuples will pass. All these remaining tuples are already failed. They are already failed. Yes or no? Is this clear? Now you are doing grouping by A. This is your next step. Now you are doing grouping by A. How many groups? Two groups. One group is this, another group is this. You are doing grouping by A. So now two groups are created. Okay, is this clear? One grouping is this, another grouping is this. And finally, now you don't have to look at the first line. What will be the answer? How many tuples will be there in the output? You don't have to worry about the first statement. Number of groups, two groups are there. So output will have two tuples. But anyway, tell me what are those two tuples? For sake of completion, what are those two tuples? For sake of completion, the final output will be, okay, these are the attributes A. The final output is something like this, that you have A, there is sum of B, and there is count of A. You can see, so there will be two tuples in the output. So A value 2, A value 3. Okay, these are the output tuples, A value 2, A value 3. You can see sum of b, that is 4 8, and count of a, that is 1 2. Is this clear? 2 4 1 3 8 2, these are the two tuples. Is this clear? So the number of tuples in the output, that will be 2. Did you notice what is the tricky part here? Tell me in this question, what do you think is the most tricky part where students can make mistake? What is that? That is where condition. This where condition, yes or no? Okay, because this tuple will fail. This tuple is going to fail. Okay, I hope this point is clear. Now just let me quickly ask you, if I do grouping by b, let me do grouping by, maybe grouping by c. I am doing grouping by c, and the condition I am putting, that is c is less than 3. Okay, c is less than 3, or c is greater than equal to 3. This is the condition I am putting. Okay, c is less than 3 or c is greater than equal to 3. Okay, is this clear? From R, select, I have to put c here. I have to put c here. Okay, and let me write, for example, count star. Now you tell me the answer. What is going to be the answer? Number of tuples, that will be. So first of all, this condition who will satisfy? First you will do the from clause, then you will do the where clause. This condition will be satisfied by whom? By non-null tuples where C is non-null. Yes or no? Where C is non-null. So these tuples will pass. These four tuples, they will pass. Okay, yes or no? And these tuples, they will fail. Now you tell me, group by C. We are grouping by C. So how many groups will be created? This is the third thing. How many groups are going to be created? So you can see 1 2 3 4, 4 groups will be created. Okay, the answer will be what? Answer will be 4. Okay, if you want the actual answer, the output is like this. The final output, that will have 4 tuples. There are 2 columns. One is count, one other is count star. One is C, another is count star. Okay, so the answer will be, so the value of C, you can see 4 3 2 1, and count star is 1 1 1. Is this clear? So 4 1 3 1 2 1 1 1. This is the answer. I hope this point is clear, and I hope you are getting that any variation you can handle. Is this clear? For example, let me create groups based on A comma C. Let me create groups based on A comma C. Okay, and where condition, let's assume I am not putting any where condition. There is no where condition now. Okay, select, should I put A comma C here? Yes, of course, A comma C I should put here. Can I put B here? I cannot put B here. Okay, but I can put, for example, I can put average of B. That I can do. Okay, no one is stopping me. I can do average of B, I can do average of C. Aggregation I can do on anyone. Okay, now tell me the answer for this question quickly. So how many groups will be created? How many groups? So you can see 2 null, 2 null. They are one group. Okay, so one group is this. See, this is your group number 1. I can call it group number 1. Another group is this. Let's call it group number 2. Next, 2 4 2 3, 3 2 3 1. So they are different groups. This is group number 3, group 4, group 5, and group 6. Okay, so let me write it. Group 3, group 4, group 5, group 6. Correct. So the answer will be what? The number of tuples will be same as number of groups. Number of tuples, that is going to be same as number of. Okay, so very simple. There will be total 6 groups. You just tell me about the group number 1. What will be the output? In the output, just tell me about the group number 1. In the output, you have A, C, AVG, B. Yes or no? You have A, C, AVG, B. What about the group number 1? For the group number 1, one tuple you will get. One tuple. So AC value is 2, 3. AC value is 2, 3. And AVG of, actually the interesting part will be AVG of C, right? Okay, the interesting question will be AVG of C. The interesting question that will be AVG of C. That will be interesting question. So tell me AVG of C. For this group, AVG of C. So remember this AVG, this will ignore the null values. Now you have empty, now you have empty table. For empty table, AVG that will be null. Okay, so AVG of C that will be null. Clear? So 2, 3 null. What about group B? For group B, what will happen? That will be null, 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 null. Okay, like this. Group group C, group 3, and so on. Okay, so total 6 groups will be there. Very simple. Now let's move on. I hope you understood all these points. Clear? Any variation can you handle? What are the tricky part? What is the tricky part? Where? Before creating the group, please apply the where clause. Don't forget about where clause. That is very important. Okay? Because you can make mistake in the where clause. That is the possibility. Okay, now let's move on. Tell me the answer for this question quickly. This is question from the Ullman book. How many tuples in the output? A student is saying, sir, there is a mistake. In G1, it will be null in C field. In G1. Okay. AC, that is null. Right. Okay, this mistake we made because AC, see, the AC value is 2 null. Okay, yes or no? In the group 1, the AC value is 2 null, 2 null. So that will be 2 null. And average of C will be null. There is no other mistake, right? So thank you for pointing out, Gaurav. Thank you. Now let's move on. So tell me the answer for this question. This is Ullman question. Quickly tell me the answer. The result of this group by A comma count of B. So here you can easily see you will do group by A. So one group will be created. One group will be created. The value of A is unknown. Value of A is null. And count of B, what that will be? Count of B, that will be 0. So the answer will be null comma 0. Yes or no? Very simple. Because remember, this A value, one group will be created. This one group will be created. In this group, A value is null. And count B, this count will ignore the null value. It will ignore null value. For empty table, count is 0. For empty table, count is 0. So your answer will be null comma 0. This is your answer. Okay. Is this clear? So very simple. The answer is null comma 0. You can easily see. Now in the same question, if I ask you, what is sum of B? Maybe multiple things I can ask, but for now you just tell me what is sum of B? What is sum of B? What is count star? Tell me these things. Okay, what is count star, or what is also, let me ask, what is count of A? What is min of B? So tell me all the answers. This is my question. You tell me the answer. Very simple. One group will be created. This is the group that will be created. Okay, so you can see there will be one group. Now, in this group, the output will have these columns. The columns will be like this: A, sum of B, count star, count A, and min of B. Okay, so one group is there, so one tuple will be there, right? Yes or no? There will be only one tuple in the output. So you can see that in this group, the value of A, that is already null. There is no problem. Now, this is sum, this sum of B, this is sum of B. This sum will ignore the null value. For empty table, sum will be null. Okay, so sum will be null. Count star, this will always count the number of tuples within the group. number of tuples within the group. So number of tuples within the group, that is 1. Yes or no? Number of tuples within the group. This count A, this will ignore the null value. For empty table, count is equal to 0. Min B, this will ignore the null value. Sorry, this is count A. Count A will ignore this null value. Count A will ignore the null value of A. For empty table, count is equal to 0. Next, for min B will ignore the null value of B. And for the empty table, min is equal to null. So your answer is null, null, 1, 0, null. This is your answer. Is this clear? You can read this explanation here. When you have sum B, the answer will be null, null. If you have sum B. Tell me the answer for this question quickly. This question I have taken from Stack Overflow. RAB is a relation with single tuple null, null. You have a relation with a single tuple null, null. So there is a single tuple in this R, that is AB, and that is null, null. So tell me the answer. Here, what will be the answer? Okay, very simple. For this query, the answer will be, there will be count of B. So the answer is going to, you can see the value of A. We are grouping by the value of A. Value of A is null. And count of B. This count will ignore the null value of B. For empty table, count is equal to 0. So that will be null comma 0. Okay. For this question, the answer will be A count star. For this question, answer will be null comma 1. Okay. And for this question, answer will be, what that will be? A comma sum of B. So that will be null comma null. Okay. So the answer will be, you can see null 0, null 1, null null. Okay. So that's it. I hope you understood all these points. This you can see. Tell me, in this query, do we have having clause? Is there any having clause here? Select, there is select, there is from, there is group by. Okay. There is no having clause. So what will be the number of tuples in the output? How many tuples will be there in the output? That will be number of groups. Yes or no? Now, first you will apply from user table. This is the user table on your screen. This is the user table. Now, in this user table, so let me write it. This is your user table. In this user table, from user, this is your step number 1. Now, then you will create the group based on ages. Based on age, you will create a group. How many groups will be there? 2 groups will be there. Yes or no? In one group, these two will be there. In another group, these two will be there. So you can see one group, another group based on ages. Okay, based on age. Now you can see we are selecting age, average popularity. Okay, so you can see for every group, one tuple will come in the output. For this group, one tuple in the output. Okay, similarly, for this group, one tuple in the output. For every group, one tuple in the output. Yes or no? So like this, you can easily see. So I hope you have become expert of group by clause. Tell me, are you comfortable with group by clause? Okay. One very important thing I want to tell you, that is group by without aggregation is valid but useless. Did you notice one thing? When I started teaching you group by, from the beginning I am telling you that group by application is with summary. Group wise summary. We want group by because we want group wise summary. For every group we want aggregation. Did you notice that? So can we apply group by without aggregation? Can we do that? Let me know. Can we apply group by without aggregation? Yes, we can apply. We can do that, but it will be useless. Okay, actually group by without aggregation, this is same as select distinct. This is same as select distinct. Let me give you one example. Okay, with example, this point will become very clear. So let's assume you have group by. Okay, group by some attribute A, and in the select, I do not put any aggregation. I have to put A, right? Yes or no? I have to put this A here. Can I put B here? I cannot do that. Okay, so I have to put A here. Okay, let's assume from some from table R. Okay, let me also give you where. Let me also give you where A is equal to 3. Okay, and you already know that group by A. So very simple. Now you can see there is no aggregation. Now you take the table. I am giving you this table R where you have A, B, two attributes you have. Okay, let me take some variations. For example, maybe I can take 2, 1, 2, 3. Okay, 2 null, null 2, null, null. Okay, some variations I am taking, and maybe 3, 3, 1, 3 null. Okay, so let's assume some more tuples. Let me take so that I can cover all the variations. For example, let me take 3, 3, okay, and null comma 3. Okay, so let me take this. Now tell me, what will be the answer? One more tuple. Let me take one more tuple, just one more. That is null, null. Okay. Now you tell me what will be the answer. So you can easily see first step will be from R. This is your first step. The second step will be A equal to 3. So which tuples will be gone because of A equal to 3? So you can see A equal to 3. So A equal to 3, or maybe I can say not equal. Okay, else let me put not equal. Not equal to 3. Okay, let me put not equal to 3. A is not equal to 3. So tell me, if I put not equal to 3, then which tuples are gone? So you can see these tuples are gone. These are failed. Yes or no? These tuples failed. Sorry, all these last, the all of these actually failed. All of them actually failed. Okay. So now, now you are creating group based on A. So only this group will be created. Okay. So that's it. One group will be created. And then what you are doing, you are selecting A. So your output will be what? You are selecting A. For every group, one tuple. Yes or no? For every group, one tuple. Is this clear? For every group, one tuple. Now, did you notice that the same output you will get? Okay, one very interesting thing I'm telling you, I'm going to tell you, that is this same output you will get if you put, forget about, see, there is no aggregation, right? There is no aggregation. So the same output you will get if you just put select distinct. Okay. See, this is an interesting point, that the same output you will get if you put select distinct. Select distinct. Okay. Just ignore the, just remove the group by. You don't need group by. There is no need of group by, because group by is useless when there is no aggregation. See, there is no aggregation, right? Because there is no aggregation, group by is useless. This group by is same as select distinct. Okay, just notice, for this query, what will be the output? Tell me, for this query, what will be the output? You will say that for this query also the same output you will get. Agree? For this query also, the same output you will get. The output will be A value 2. Is this clear? And for this also, the output will be A value 2. Is this clear? So very simple point, right? Okay. Understood? Let me know. Did you understand? One more example. Let me take one more example. Let me remove this where condition. Now you tell me the output. Again, they will give you the same output, but tell me the output. What will be the output? Again, they are going to give you the same output. Okay. So group by. Okay. So now tell me. One thing you notice, is there aggregation here in this group by? In this group by, is there any aggregation? There is no aggregation. So group by is useless. Okay, group by is useless. You can just simply put it select distinct. You can remove group by and you can put select distinct. Let me tell you, they will give you the same output. You can check it. Okay, for example, here, group by A, how many groups will be created? How many groups will be created? The output will be A. The output will be A. How many groups will be created? So one group will be created for A equal to 2, another group for A equal to null, another group for a equal to 3. Yes or no? So these are the groups that will be created. This will be the output. You tell me the output of this. Select distinct A. Select distinct A. Do you remember the definition of distinct tuples? Do you remember the definition of distinct tuples? That will be useful here. Definition of duplicate tuples. Okay, do you remember that? Duplicate tuples. So for example, if you remember, I told you that these tuples, for example, null 2, they are duplicate, right? They are duplicate. Okay. If you remember, I told you null, they are duplicate. We have already seen the definition of duplicate tuples. That will help you here. So now you tell me, from R, select distinct A. Distinct A. So the answer will be 2, null 3. Did you notice same output you are getting? Please tell me. This is the interesting point, right? That group by without aggregation is same as select distinct. Group by without aggregation is useless. That is same as select distinct. Okay, is this clear? Please tell me, did you find this point interesting? This is given in the Ullmann book. This interesting point is given in this Ullmann book. You can see this is group by. There is no aggregation, right? There is no aggregation. Okay, so group by without aggregation, this is same as select distinct. It will be same as select distinct. Is this clear? So very simple point. So this is what we can see. If we apply group by without aggregation, then it will be useless and it will be same as select distinct. So this important point, I can say this interesting point I wanted to tell you. I hope you understood this. I've given you the example also. Okay. For example, this example, you can see this query group by we are using without aggregation. So this is same as select distinct. They will give you the same result. Okay. Let's move on now. So that's it. We have seen the group by clause, and the SQL query template will be, this is the query template. These group by attributes you have to put in the select clause that I already told you. Okay. So tell me, where is the error? What is not allowed in SQL? For example, if I do this select, if I put like select A comma B, okay, from and group by. In the group by I have A. So means here I have A comma B, and in the group by I have A. So is this allowed or not? Okay, let's assume there is count also. No problem. There is count star also. So now you tell me. This is not allowed in SQL. In any version of SQL. This is not allowed in any version of SQL. Correct? Okay, not allowed in any version of SQL. In any SQL version. This is not allowed in any SQL version. Okay. See, a student is saying that, but it will run. But it will run. If you run this, it will run. One thing I want to tell you. See, let me tell you from the C language point of view. For the GATE exam, you study C language, right? Okay. Now, let me tell you, if you create the concept by running the program, if you create your own concept, then that is wrong. Because in the C language, many things are undefined. See, I have seen many students what they do. For example, they will do some experiment in the C language. They will do this type of experiment, printf. Okay, printf, some experiment they will do. Plus a, plus a. Okay, have you done this type of experiment? Plus a, plus. Okay, some this type of experiment have you done? Maybe. So in the C language, this you will see many times that students what they do, they will run this, and after running some multiple experiments, they will run, and then they will create their own concepts in the mind. They will be thinking that I have created the concept. Okay, by running the program, they will run this program, then they will do some more experiment, then they will do some more experiment. Okay, they will do this type of experiment, plus b, plus b. Okay, some type of experiment they will do. Okay, and then they will think that I've created the concepts. Okay, I've become the Dennis Ritchie. Yes or no? The inventor of C language, the rules of C language are created by me. So let me tell you, when you run the C language program, when you run the C program and then you create your own concepts, then those are wrong. Concepts are concepts. See, whatever program you write, whatever, for example, this is undefined in C language. C language does not say anything about this. Let me tell you, C language does not say anything about this. Okay. So, but if you run this on some compiler, definitely some output you will get. If you run this on 10 different compilers, you may get 10 different outputs. Okay, because these things are undefined in C does not mention anything about these. What will happen, that depends on the compiler. Okay, different compilers can give you different output. Is this clear? So remember, to study any language, C language, if you want to study the rules of C language, then don't run the program and check the output. First you learn the concept, then run the program. Okay, some students they do opposite. First they run the program, then they create concepts. Is this clear? So the correct method is, first you learn the concept. Okay, you study the correct concept first, you understand it, then you run the program. Don't go in the other way. Now here you can see, I told you that this is invalid. This is not allowed in any version of in any version of SQL. This in select you are putting B, but here you are not putting B. This is not allowed in any version of SQL. Okay, but if you run this on some SQL processor, okay, on some SQL compiler, if you run this, definitely some output you will get. Definitely it is possible that you will get some output. Okay, some SQL compiler will say it is invalid, some other SQL compiler will give you some output, and then you will be thinking, I understood the concept, now I have become the what was that, god of destruction. Okay, so so that dialogue you will mention. So again, so first you learn correct concept, then you run the program. Okay, to create the concept, don't run the program. Is this clear? I hope you understood. Okay, so anyway, so remember, this is not allowed in any version of SQL. What about this? If i put if i put AB here, but I don't put B here, now tell me, if I put AB here but I don't put B here, now what? I can put count B. Remember, aggregation I can put on anything. It doesn't matter. I can put aggregation on anything. But I'm putting AB here. I'm only putting A here. Then this is not allowed in SQL 92. In SQL 92, this is not allowed. It is allowed in SQL 99. It is actually allowed in other SQL versions, SQL latest versions. Okay, but from the gate exam point of view, we stick to SQL 92. This is for gate. For gate exam point of view, you just stick to SQL 92. Is this clear? Let's move on now. So this is what I'm telling you. Read this, please read this. This is must rule for group by clause. Okay. So every unaggregated attribute of select clause must appear in group by clause. Yes or no? This will happen in every version of SQL. In every version of SQL, every unaggregated attribute of select must appear in the group by. Okay. Now, aggregated attribute can be anyone. Okay. You can do aggregation on any attribute. Any attribute you can aggregate. Okay. Now, SQL 92 rule. Let's see SQL 92 rule. That is, the group by attributes must be in the select clause. All group by attributes must appear in the select clause. Unaggregated. All group by attributes must appear in select clause unaggregated. Okay, so this is SQL 92. I hope this point is clear. You can see, you can read this SQL 92 standard. Okay, these two rules you can read. Anyway, we have already seen. This is a meme I created. When you put some attribute in group by clause but not in select clause, then SQL 92 nahi manenge. Okay, you can read this meme. Next, for the gate exam, we will follow SQL 92. Is this clear? So look at this. Here you can see group by A's. We are putting A's here unaggregated. Aggregation you can do on anyone. It doesn't matter. Okay, so this is a correct query. Is this clear? What this query is doing? Look at this query. This is grouping by A's. So for every A's, there will be a group, and For every group, you are finding average popularity. For every group, average popularity you are finding. Okay, very simple. Now let's move on. So we have seen number of groups is equal to number of rows in the final output. This will happen when, which things you have to take care. This will happen, first of all, when no having clause. When no having clause. Okay. And the second, after where clause. These things you should take care. After where. Is this clear? So number of groups will be equal to number of rows in the final output. Let's move on. Now, if there is no group by, then what do you think? Every tuple will be a group, or the entire table will be a group? Think about it logically. Logically think about it. If there is no group by, if there is no group by, then the entire table will be single group, or every tuple will be a group? What do you think? Let me know. If there is no group by, if there is no group by, see, just think logically. If there is no group by, okay, let me tell you. Consider this query. I am giving you a query: select avg, or maybe sum of a from R. Is there any group by here? Is there any group by here? Just tell me. There is no group by, right? Okay. There is no group by. So now you tell me, how many tuples will be there in the output? This will give you how many tuples in the output. From R, sum of A. How many tuples you will get in the output? You will get only one tuple in output, right? You will get one tuple. Now you think about it. If every tuple is a group, then will you get one tuple? If every tuple is a group, will you get one tuple? No. No. The entire table is a group. Then you will get one tuple, right? Yes or no? Is this clear? Logically, you think logically. If there is no group by, then you will get one tuple in the output. You can see for this query, you will get one tuple in the output because the entire table is a group. So remember, if there is no group by clause, if the group by clause is removed, then the entire table is a single group. Entire table is a single group. Okay, is this clear? So you can see one tuple. If you put aggregate, then one tuple in the output. Also, one more thing. Can I put some other attribute like sum of A? Can I put unaggregated attribute here from R? Can I do this? In the last lecture, we have seen this is invalid. This is invalid. If you remember, if you have aggregation, it's like this. See, if there is aggregation, then this attribute must come from the group by. Yes or no? Do you agree? If there is aggregation, aggregation is fine. This aggregated attribute, this is fine. But in the select clause, you have this. So this must come from group by. There is no group by, so this should not come. There is no group by. Okay. So anyway, this is invalid. So very simple point. Don't think too much. Okay. So just if there is no group by clause, then entire table is regarded as a single group. That's it. That's it. Okay. So for this query, one tuple in the output, and this query is invalid. I told you in the last lecture, when you have aggregation, then you cannot put unaggregated attribute. This we have seen in the last lecture. Okay. So very simple. You can see here, you will get one tuple in the output. Okay. From the user table, average popularity. So you can see this entire table will be created, will be considered as a group. There is no group by. There is no group by. So all the entire table is one group. And for one group, one tuple will be in the output. Okay. So the output will be average popularity. That's it. So we have seen all these points. Is this query valid? Is this query valid? Group by age. Can you put UID unaggregated? See, group by age. Can you put UID unaggregated? No. So this is invalid query. You can see wrong. What about this? What about this? There is no group by. We have no group by. If there is aggregation, can you put an unaggregated attribute? There is aggregation. Can you put unaggregated attribute? The answer is no. So again, this is wrong. In the last lecture, we have seen this. If there is no group by, and you are putting aggregation, then you cannot put unaggregated attribute. Okay, now we will study having clause. We have already seen group by clause, all the variations, all the rules, everything we have seen. Now we will study having clause, and this we will study in the next part. In the next part, we are going to study having clause. Also, we will study nested queries. Okay, that is what is remaining. Having clause, order, there is order by clause. Okay, so these two clause we have to study. Let me tell you the remaining things. Having clause is remaining, order by clause is remaining, and nested queries is remaining. That's it. Okay, everything else we have seen. So please tell me, did you like this session? Let me know. So this was SQL Complete Summary Part 2. The Part 1 link you can find in the description, and let me know in the comments whether you liked this session or not. Okay. So thank you everyone. Remember, I have told you each and every concept, every important point, every variation, okay, every type of example. So everything we have covered in this SQL Complete Summary. And if you watch only this SQL Complete Summary, if you watch part 1, part 2, and the part 3, if you watch all the three parts, then you will be able to solve each and every gate question. Each and every gate question you will be able to solve, and also in the future, if any gate question comes from the SQL, you will be able to solve. Okay. Thank you everyone. Thank you everyone. Please comment. Please like and comment. Okay. Thank you.